Okay, good morning, my dear future child accountants. Okay, so today is going to be a 2 days crash course on mathematics and statistics. Myself, CA Chinmay Hegde. Let me give a quick introduction, not much time because it's a crash course. I cleared the exam in 2010. I'm a rank holder in all the 3 levels. In the foundation, I got 13th rank. Intermediate, I got 3rd rank. And in the final, I got 39th rank. So after 2010, I've joined a equity research firm. Worked there for about 5 years. And then now at present, I'm into full-time teaching and trading. That's what I do for day-to-day living. The expression what you are having in the face, many people also will have that after passing the exams with rank in all the 3 levels and having the corporate experience, why to go for teaching field? Many reasons are there, but I'll try to give the honest and the real reason. You know, after becoming CA, you have two choices. Either you can be in practice or you can be in employment. One of them you have to choose. So being in employment means it's a process of getting paid for scolding from your boss or from managers. Higher the level of scoldings, higher will be the pay scale. And what is practice? It is also a process of getting paid, but for scolding from two sets of people. Because being in practice, you have to deal with government who don't understand how the business works, and you have to speak to clients who don't understand how the government department works. In between CA is a sandwich and you get paid more for that. So is there any profession where you can scold somebody and get paid for it? Yeah. Teaching is the only profession which has that privilege. And one more important reason is anywhere, you know, when you pay something, you want more. If you go to hotel, you pay some 50 rupees, you want dosa, you want chutney, you want sambar, you want extra chutney, extra sambar, because you paid for it. But in the classes, if faculty says, okay, today let's finish the class at half time itself. Some of you already happy, but don't worry, I'm just giving an example. But if you feel, I mean, that's the reaction that you paid for it, but you get less, you are more happy with it. I think it's the only profession which that can happen. But anyway, I believe teacher is a person who is a permanent student because the learning never stops. So that's the reason why I have chosen this profession. Anyway, it does not matter. So let's go into our subjects. We have very less time. Let's quickly go through your life so far. That's how you started when you are started initially, and over a period of time how the role has reversed. And as you move in CPT, now we are calling it as foundation, IPCC final, how you move forward in life. And CA syllabus is one where nobody knows how much is the CA syllabus, it keeps growing. I can also witness this in class. It's always the case, but somehow in examination, the role will get reversed. And this is one common situation of CS students, keeping all the books open and with the calculator, even if it's a law subject, we need that. And we will be reading throughout the day. And of course, when you pass the exam, the world is at your feet. Okay. So throughout you pass the examination, keep these three sentences in mind. Heated gold becomes ornament, beaten copper is called as wire, compressed carbon is called as diamond, heated, beaten, compressed person is called as a chartered accountant. There is no exceptions and there are no exemptions. So in this process, you will definitely feel you are missing something, you feel irritated, frustrated. Then tell yourself they are the common phenomenons in CA student career. There is no exception thing about it. Anyway, keep these things in mind. It will help you when you move forward. Okay, so let's come to our subject, which is full form of maths. Many people think this, that mentally affected teacher harassing students. So that full form is called as maths. A few simple tips which I'll try to share. As compared to mathematics, statistics will take less time to solve. The reason being, people call it as it has theoretical questions, but I will say it's a conceptual questions. So more than numericals, concepts are important. So statistics takes less time to solve. So comparatively, I would say that you can cover the statistics faster. And in mathematics, you will have lot of shortcuts possible. As and when we discuss, we are going to do it. One of them definitely being substitution method. That is all the 4 options you tried. Some people call it as options method. Some people call it as plug-in method. We'll try all those methods when we solve the problems, and other shortcuts are also there. This also you should keep it in mind. Don't attempt if you are not sure of options, because it will have negative marks. So every marks you have saved, even negative marks if you avoid, that also is like a indirectly you have saved it. So if you're not sure, don't try to guess the answer and don't go for it. It's okay not to answer some questions. And if you are 50-50 chance, then you can go for some guess. Otherwise, if you're not sure about the questions, then do not go for solving that problem, because keep the negative marking in mind. Okay. So in our syllabus, we have 2 parts. One is mathematics part and statistics part. I will take up first statistics part, then I'll come to mathematics portion. So today we'll focus on statistics, which is relatively easier to apply. And we have one chapter. I mean, this is quite a few things are there. In mathematics, we have one chapter which is calculus, differentiation and integration. That I would not like to do it in depth in the short period of time. If we spend time on that, other things will get adjusted, or we have to do a compromise on that. So what will I do? I have included some problems because in the examination test comes. So whoever interested, please solve that problem today when you go home. So tomorrow when you come, I'll share the answer keys of those chapters, so that whoever is trying, you will get some support. Otherwise, we will focus on the chapters excluding the calculus part. Calculus also towards the end, I'll spend some time on the basics, at least is clear, but will not be giving much importance as far as the calculus is concerned. Okay, so apart from that, we'll start with statistics today, and tomorrow we'll go for mathematics. So before we start, if you have any questions, any particular area or problems, you can always ask. Do you have anything in mind? This particular area, this particular formula, this particular type of problem, if you have any issues, you can raise it, so that while doing that concepts, I can cover it. Don't look at your friend, because in examination also this happens. When you put a question paper, you look at your friend, and your friend is already looking at you. Nangu gottilla, we'll see you next time. So these are common situations. So do it independently. So if you have any specific concerns on any particular chapter or a concept or a formula, if you have anything in mind, you can ask. Okay, if nothing is there, no issues. But if you have anything, when I'm doing those concepts, I can go slowly on those areas. Okay, so the format of discussions will be this. For the first maybe 15-20 minutes of every chapter, I will take an overview of each chapter in the form of charts and so on. Then I'll give you some time for you to read. We'll discuss the doubts, and then we'll go for the problems. That will be the structure. And it's going to be full day sessions, so morning to evening will be difficult to focus. The studies says that the time span, maximum time span of attention of any human being is 20 minutes. Beyond that, things will definitely slow down, but we are going to spend hours together. We don't have a choice. So in between, I'll try to tell some jokes. If you feel like it, laugh at it, but I don't force you. Earlier people used to tell, or I used to tell that I will tell one joke, and then people used to react. Then one of the students told me in the class, you don't announce. We will decide. If it is a joke, we'll laugh, otherwise we will not. So from that onwards, I don't decide. I'll leave the decision to you. You take the decision. And just keep it in mind. At this age, you should laugh as much as possible whenever opportunity comes, whether it's a poor joke or PJ, or it is not at all a joke, or this is also a joke. I've seen different kinds of reactions. At this age, if you don't laugh enough, if you want to see what happens in the morning classes, no, when you walk nearby park and all, you observe what happens over there. You will have laughing clubs. They are forced to laugh. Some ha 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 and will be there. Like, by looking at them, we don't feel like laughing. We feel pity for them. The reason is when they were young, they were too serious. They were not having enough good time. So if you want to have similar situations, you also be so much serious. So in life, always be sincere. You don't have to be serious. Those two are different terms. Be sincere, always to the point, whatever work you do, but that does not mean you have to be serious. Okay. Coming back, let's start with the first chapter in statistics. Statistical description of data. So basically the world is now full of data points. Everything is built around data. So it's important everybody has some basic concepts of the statistics terminology at least. So this chapter revolves around that. Just imagine how the future will be. You are now coming to class, writing down some notes, going to exam and writing it down. In the future, how it would be running to your children's stage, next children's stage, generations. How it would happen. So when you don't come to class, or even if you come to the class, you don't write down anything notes. I just click some button, the notes will get automatically dispersed to your mobiles, your laptops, or your tabs and so on. So no need to write down any notes. Examination also, you don't have to write down anything. Maybe you can upload your answers. It is PDF format, Excel format, XML format. So verification also gets done automatically, and results will be maybe posted onto your Facebook wall, where you get 3 kinds of reactions. You have like, share and comment. Like will be by your parents. That's what they do. Whatever it's there, they will press the like button. Comment will be for your friends, because they'll comment like, you told me you'll get 91 marks, but in exam only 19 marks came. That's the kind of comment that your friends will put always. And last one is share, and for that only one creature is created, that is called as relatives, who is there for the purpose of sharing. And the best part is, 6 months later, Facebook will throw a memory back. 6 months back, you wrote the examination, you did not clear, do you want to write again? With tagging automatically others, with examination form automatically filled up. These things can happen. So in the future, just be ready, because it's much, much fast, rapid changing than what we can think of. So everything is built around data. So even if you take your mobile phone, you just start Facebook, automatically the suggestions will start coming. How does the Facebook know that these are likely to be your friends? When you open Google, again the ads will come such a way that it suits your interest. So you had to search for good hotels in Bangalore, some things will come, and automatically next time you open, those ads only will come. So these are all built around statistics, algorithms. Many things are built on statistics. So real life, if you can make use of it, it's a powerful tool. Okay, coming from examination point of view, statistics basics definition, we are having in 2 definitions. One is singular sense, which is about quantitative, means only numbers. Then we have a plural sense, means we talk about both quantitative as well as qualitative. So when I say only, signs of averages, Virat Kohli average in T20 is like 35 runs. If I say only numbers, it is singular, quantitative. If I also focus on why he scored or which places he scored, if I focus on the qualitative aspects, that is plural sense. Statistics has some limitations. Statistics is not going to be foolproof. It is not 100%. It depends on always the interpretations we do, and people can use statistics to interpret wrongly also. So one person did the experiment like this. If you mix water and whiskey, it's bad for health. If you mix water and cocktail or whatever it is, vodka something, it is bad for health. If you mix water with some other alcohol, it's bad for health. So what is the conclusion? Water is bad for health. It's common in all the three places, right? So whenever water comes, it is bad for health. So statistics is that tool. If you don't use it properly, it can always be misguided or it can be misused. So limitations of statistics are there. It deals only with aggregates. It does not deal with individual data points. That means it's just a representative. So if I say in 10th standard, I got an average of 78%. Does that mean every subject I got 78? It just on an average overall, it is 78 marks. That's what overall I mean by aggregate. Statistics deals with aggregate, not with individual numbers. And limitations, it deals with only with numbers. That is mostly with numbers, though it's not always. So statistics also to be understood with pinch of salt. Just because some number says something does not mean that it is always giving a true picture. Especially during elections and all, every party comes with a number supporting its position. So every party may be correct, but every number may not be correct. So you should be careful while applying any data point. Mostly concerned with numbers, but not always. Classification of data. I mean, how once we collect the data, how do we classify? How do we divide? Based on measurement, we have two methods or two numbers. One is called as attribute, other is called as variable. Do you take in between the class also in the crash courses? Do you take breaks in between or continuous for a morning? You take break. How long you take break? 10 minutes. Anyway, yeah, no, just give an example. See, whenever I asked you something, first I asked you, do you want a break or do you take a break? You said yes. You did not tell how much. So that is an example for attributes, where something is expressed in words, not in numbers. Yes, no, male, female, place of college, drinking habit. These are all attributes because they are not expressed in numbers. Now, when I asked next question, how long you need a break, then we went for numbers, and that is what is called as variable or quantitative. So if we expressed without a number, it's qualitative attributes. With number, that is quantitative variables. And there also have two varieties. One is discrete variable and continuous variable. Discrete variable means absolute number. Like if I ask you how much time you need, you say 10 minutes, that's absolute number, that is discrete. Or you tell 10 to 15 minutes when you express in a range, that becomes continuous variable, this quantitative data. Then based on the source of collection, where you get the data from, we have two varieties, primary and secondary. Primary means directly from the source, and secondary means data is already collected and we take it from them. So secondary source, essentially when you take the data from internet, from Facebook, WhatsApp forwards, or government agency has already collected and you take the data from them, that's called as secondary data because data is already collected and stored. Primary data is when you directly go for the source, like interview method, maybe physical interview or telephone interview, or a mailed questionnaire, like a feedback form you get. Even after the class also you will get that mailed questionnaire where you get the, even when you go to hotel and all, they'll ask you how is the response, how was the ambience, you fill up something, that is mailed questionnaire. Observation, as the name suggests, a simple observation method. Secondary data, where government data is already collected, maybe from private organizations like internet, Facebook, government organizations. Government also has a statistical department which collects the data like GDP of a country, population level, all these things are government already collected. So that is what is secondary data. And also quasi-government. Quasi-government means public and private, both partnerships will be there. That's called as quasi-government organizations. And how do we present the data? We have three varieties. One is textual format, tabular format, diagrammatic. Textual is in the form of words, sentences, paragraphs. It is used for reports when you want to make rules in the factory, laws in a factory. So when you want something very detailed, we go with textual. For statistics, mostly we use the tabular format, that is in the form of rows and columns, and diagrammatic, but is in the form of pictures. So we have mainly three varieties here: pie chart, bar diagram, and line diagram. Pie chart looks like this, by a circle dividing into various percentages. That's pie chart. Then line diagram, by joining the data points. For example, sales in different years. Product 1, how the sales have grown. Product 2, how the sales have grown. That joining the points, you get the lines, that is line diagram, represented by rectangular bars, that is a bar diagram. So in science class, how many boys are there, girls are there, in economics class, in language class, and so on. About the division of things. So you represent by rectangular shape, that's called as bar diagram. So 3 types of diagrammatic presentation. We have to discuss a little bit more about tabular. I'll just come to it later. Then we have one more thing called as frequency distributions. Again, representing in the form of tabular things for statistical part. Frequency means how many times something is repeated. Class limits, so we express in a range like between the age of 20 to 30, how many employees are there in a company. 30 to 40, how many employees are there company. That's called as class limits. Class boundaries without gap. So if I write it as 10 to 19, 20 to 29, that is, if there is gap, that is not called as class boundary. But if you write continuously, that is, I write it as 10 to 20, 20 to 30. If I write like this, where there is no gap between the upper limits and lower limits, that's called as class boundary. Class width, the gap between the lower limit and upper limits. Frequency density, the formula is frequency divided by class width. Frequency is in that class interval, how many people are there. Width is the gap between lower limit and upper limit. A relative frequency, that is the frequency of that interval divided by the total, the capital N. So basically it tells you how much percentage of the total number of employees are in the particular frequency. Or if I tell you like this, between 0 to 60 marks, let's say there are 50 students and total number of students is 200 marks. So frequency is 50 and total number of students becomes 200. So 50 by 200, that is maybe like 0.25, that represents the relative frequency. Class mark is the mid value, so lower limit plus upper limit divided by 2, that's called as the class mark, or also called as mid value. When you represent this frequency distribution in graph, you get 3 more varieties of graph. One is called as histogram. Histogram, by joining the midpoints, the difference between histogram and bar diagram is, bar diagram, if you remember, there are gaps between the first one, second one, they are not joint, they are separate. But when you represent in a frequency distribution, they are together, there are no gaps, that is why it is histogram. Continuous, it is not having any gaps in between, that's called as histogram. And when you join the midpoints like this, of the midpoints of histogram, then you get a line like this, that's called as a frequency polygon. Then we have one more term called as cumulative frequency. So how do you represent cumulative frequency? For example, between 0 to 30 marks, there are 70 students. 30 marks to 50 marks, there are 30 students. And 50 to 100 marks, there are 20 students. So totally 70 plus 30 plus 20, 120 students. So if I ask you, how many students are scoring less than 30 marks? The second column represents number of students. So number of students scoring less than 30 marks is 70 students. But how many students scoring less than 50 marks? We don't just say 30. When I say less than 50, it includes 70 also, it includes 30 also. So that is what is called as cumulative frequency. When you keep adding the numbers, that is less than cumulative frequency. If I start with 120 and keep subtracting the numbers, that's called as more than cumulative frequency. And when you represent that cumulative frequency in the graph, that's called as ogive curves or ogive curves. And the intersection between those two, so this is the lesser than CF, this is the more than CF. The intersection point is actually called as median. What is median will come in the next chapter. Similarly, histogram, the top of it, if you cross and make an intersection, from that you can obtain mode. So from histogram, mode can be obtained. From ogive curves, median can be obtained. How to calculate, that's not important, but you should know that ogive curves is the only graph which talks about cumulative frequency. And from the ogive curves, you can obtain the intersection point being median. And different parts of the table also you should be aware of it. We'll quickly go through that. So table in the form of rows, columns and headings. Every table will have a number that's called as table number, and the heading is called as title. And like here we told examination, and under that I'm writing December, June, December. This is called as row caption, and these are all called as the column captions, heading for respective columns. And what you write here below, the first column, that's called as stub entries, and whatever the content is called as the body of the table. Source you write on the rightmost bottom, that's called as footnotes, and entire upper part of the table, that's called as box head, including the title. Entire upper part of the table is called as the box head. Okay, so these are the things which you should be aware of as far as the summary of this chapter is concerned. So take a look at this. You should have the material. Yes, we can say that class boundary is exclusive always. Class limit may be anything, but class boundary is always exclusive. And exclusive class interval means it includes the lower limit, but not the upper limit. That's called as exclusive. It excludes the upper limit. So when I say 10 to 20, 20 to 30, 20 don't come in two places. 20 comes only in the lower limit. That's is inclusive class interval. These charts, you don't have to write it down. Anyway, you have the WhatsApp group. I'll share it. You can copy it down later if you feel like. That's your choice. So don't focus on writing it on the charts. I'll share it. But just go through the theoretical content, summary I have given. And that's also there in the material I have given. All the summary I have given in 1 or 2 pages. So you don't have to read big books on day before examination. Just read the summary. Hopefully that should cover the maximum part. So just glance through that for 5 minutes. See if you have any doubts. Okay, so any doubts on these, any of these points? I'll just put the graph for your reference, maybe the charts. Okay, so before we go to the things, I think I should have discussed one more thing about some utility in calculators. So many people may not be aware of certain functions, so I'll quickly discuss. So in calculator, you have some functions called as m plus, m minus, you have mrc, gt, mu. Let me talk about first m plus. Basically m plus stands for memory plus, m minus is memory minus, and mrc is memory recall. If you want to see what is in that calculator memory, we press mrc, and if you press mrc once more, the memory will get cleared. So if calculation like this is there, so we have like 10 into 2 plus 5 into 6 plus 2 into 5. So 10 into 2 is 20, 5 into 6 is 30, 5 into 2 is 10. You know that the answer total should be 60. But this number can be with decimals more complicated in other numbers. So how do we do it fast? Using calculator. 10 into 2 equals to m plus, 5 into 6 equal to m plus, and 2 into 5 equal to m plus. So every time you do m plus, it's getting added to calculator memory, and when you press MRC, that 60 will come. So just try it out. 10 into 2 equals to m plus, 5 into 6 equal to m plus, 2 into 5 equal to m plus, MRC. At the end, you press MRC so that you should be able to see 60 over there. And when if you're starting fresh, please clear the calculator memory, because otherwise it will get added to the memory every time. So you can press on, clear, or MRC 2 times. That will clear the memory of the calculator. Then you try fresh. 10 into 2 equals m plus, 5 into 6 equal to m plus, 2 into 5 equals m plus, MRC. If you are getting it, don't skip thinking that answer is very simple. Now it may look like very simple, but in some complicated problem, these techniques will help a lot. And you know that this is the only machine which is legally allowed in examination. Calculator, nothing else is allowed. No book, nothing else. So when you know that that is the only resource available, you should know how to make use of it. And I say that going to maths exam without calculator is like going to bathroom without water. Nobody can help you, and you can't express your pain also. So calculator is that important. And also just imagine, in maths exam, calculator stops functioning. I know we should think always positive and all, but you should also be aware of it. If the calculator stops functioning, if you don't know the question paper, you don't pass examination, that is a different reason. You know the questions, calculator not functioning, and if you are not able to perform well in exam, that's not justifiable. And that happens because, you know, in class, you always take revenge on calculator, like class not getting over, the problem is not getting done. If you're not able to understand calculator, people keep on press on. I don't know what is that on button in the calculator. Class is not getting over, you drop the calculator down, faculty is not giving the break. Just to wake the faculty up, you can break them and you drop the calculator. Calculator will not react anything. In examination, calculator will take the revenge by not functioning. So the best thing is, in examination, please carry 2 calculator. One regular calculator, one maybe small pocket calculator, or 2 regular calculator. The thing is, don't ask me what if they don't allow. If they don't allow, keep it outside. There's nothing wrong in, okay, even if you don't lose that, lose it, that's fine. But the problem always happens, you don't have a backup in examination. So always carry 2 calculator and 2 pens or pencil, whatever it is, because that is where the critical factors from examination. For those reasons and all, you should not miss out the performance. So carry 2 calculators. If they don't allow, keep it outside. That's not a problem. And don't carry scientific calci. That is not allowed. Only regular calculator is allowed. Okay. So hope you got this number. Now we used m plus. Instead of plus here in between, if it was minus, I would have pressed m minus. That's the only difference. Anyway, that you don't worry. But I would like to discuss one more point. So try it out. 10 into 2 equals 5 into 6 equals 2 into 5 equals, at the end press GT. If you don't have a GT, buy a calculator which has GT. You can do M plus also, I just told you now. But if you do with GT, It saves lot more time, especially when I come to annuity chapter, and I'll tell you how GT can be used much faster. So while buying a calculator, make sure it has GT there. So how much? I think you get 60 directly here without pressing M plus. So just have to do 10 into 2 equals, 5 into 6 equals, 2 into 5 equals. At the end, press GT. GT stands for grand total. It will do the total whatever comes after equals. So you can do with MRC also, we discussed, but GT will save time, and saving time in exam is important. Okay, that is MRC and GT. One more thing is there, MU, and that requires one small accounting concept, which is not for us, but I'll quickly cover it. In accounts, do you know the concept of profit on cost, profit on sales? You calculate those things, so that MU will help you there. I'll quickly cover it. Suppose if I tell you they have given 20 cost is 40,000 and the profit is 20% on cost. How much is 20% on 40,000 then? So hope you get 8,000. So cost plus profit is sales. So 40 plus 8,000, you get 48,000. That is straightforward. That is not a complicated one. The complication comes now. If cost is 40,000, but profit is 20% on sales. I cannot do 20% on 40 because it's 20% on sales. I don't have sales. So when I don't have sales, what I should do is I should express on sales. How do I do it? 20% on sales means 1/5 on sales. And 1/5 on sales means 1/4 on costs. I'll have to subtract 1. 1/5 on sales, 1/4 on cost. And 1/4 on 40,000 is 10,000. And 40 plus 10, therefore I'll get 50,000. This whole accounting process you would have learned. Now if I want to calculate directly, what will I do is start with 40,000. Then you press MU. 20%. 40,000 MU 20%. You get 50,000 directly. You don't have to convert profit on sales, profit on cost, etc. MU stands for markup. So from the cost to the sales, you can go for it. So simple shortcut is cost MU the percentage. That's all. Instead of plus, you press MU. That will give you sales. Okay, so these are the calculator things I just want to discuss. Many more are there. As and when we do the problems, we will cover it. Okay, let's take a list of questions from the first chapter. In fact, even we can calculate logarithms in regular calculators. Log values we can calculate. I'll tell you when I go to the log chapter. We don't require log table at all. Just using regular calculator, we can calculate. We'll come to it. We'll not rush too many things at once. These are some foundations in calculator you must be aware of. One more small thing I'll tell you. I don't know whether you know it in calculator. So if I have to do this 30, 5 into 2. So normally what do we do in calculator? Numerator we keep 30 like this. 5 into 2 we write like this, which is 10, and 30 by 10 we write it as 3. So what I can do in calculator, you can try 30 divided by 5 divided by 2. Straight away get the answer 3. Here it may look small. When we come to the chapter like, permutations, combinations, we will have some numbers like this: 10, 9, 8, 7, divided by 4, 3, 2, 1, something like this. So what I can do then? 10 into 9, into 8, into 7, divide by 4, divide by 3, divide by 2. So I don't have to write down somewhere. I can keep dividing whatever is in the denominators. So that will save some time. Number is not important. The calculator process is important. Okay, many more things are there. As and when we cover, we'll go through it. So let's solve some questions from this chapter. Information from the internet is secondary data because the data is already collected, secondary. The most appropriate diagram to express monthly expenditure is pie diagram. The reason is we divide into circle and say 30% is for food, 20% for expenditure, 10% for entertainment. So monthly expenditure we express in the form of a circle, so it is pie diagram. The chart that used logarithm of a variable is called as a ratio chart. Log basically express ratio only. When we come to logarithm chapter, I'll explain again. But as of now, you can remember log ultimately expresses ratios, the power indices. So logarithm chart is also called as ratio chart. The number of observations between 150 and 200. So you observe this is greater than 100, greater than 150, greater than 200, greater than 250. This is called as cumulative frequency. And to be specific, it is more than cumulative frequency. And when you want in between, then what you should do is you should find out the difference. So 63 and 28, find out the difference, that is 35. So whenever they give you cumulative frequency, CF, you find out the difference. So difference between 150 and 200, so that is 63 and 28, we get 35. If they ask observation between 225, I would have done 28 minus 5 as 23. If they asked you between those two numbers. So whenever they ask cumulative frequency, you find out the difference. I mean, when they give you cumulative frequency, you find out the difference. In how many cases 4 or more accidents occur? Please read carefully. It is 4 or more. So start from 4, you go till the end. Keep adding. How many frequencies are there? 8, 9, 6, 3. That is 26. 4 or more. So I have to include 4 and do the count. Number of times accidents occurred. Frequency means number of times. 4 or more. So you add all the frequency. So 4 accidents happened 8 times. Number of accidents is 4, but how many times it has happened? You can say like, daily. In how many, in 4, it may be days, just give an example. In a day, there are 4 accidents. How many days like that? 8 days. In a day, no accident. Yes, 12 days. So you can analyze, understand. It may be days, months, and so on. Recently, we have one, Bangalore-Mysore highway being constructed, and news are reported that there are accidents happening. So if you want to see really how many accidents, take a count. In a day, how many accidents are happening. So if it is in like, you can also say, okay, Monday, how many accidents, Tuesday, how many accidents, maybe in a particular day, if there are more accidents, you can take some measures around it. So that's the way you can make use of the data. Next, the curve obtained by joining the points whose x coordinates are upper limits and y coordinates are corresponding cumulative frequency is called. The key word here is they talk about cumulative frequency. The only cumulative frequency is the ogive curves, so option A. That's the only graph which talks about cumulative frequency. Histogram is used for presentation of time series, continuous frequency series, discrete, individual. It is continuous. The reason is, if you remember the graph, it is like a diagram without gaps. It's a bar diagram, but we don't give any gaps. No gaps means it is continuous. So it is continuous frequency series. The perpendicular line drawn from intersection of two ogives. So ogives can be used for finding out median. So that's what it is, median. Same thing if they asked for histogram, it would have been mode. And for this, it is median. The most appropriate diagram to represent 5-year plan outlay in different economic sectors. Again, we divide into different percentage in the form of a circle. So that becomes pie diagram, pie chart. For construction of histogram, the class interval frequency, it may be equal or unequal. Option C. Let me explain. The frequency means when you draw the histogram, I write like this. That is, I say 0 to 10, 10 to 20, 20 to 30. That means it is equal. 10, 20, 30 equal. Or I need not write equal. I can also write like this. I can have like first one is 0 to 10. Then I can have 10 to 50. Like something like this. Then 50 to 60. Again like this. So I need not have always equal interval. Even unequal interval is fine. So it is equal or unequal. Option C. If the fluctuations in the observed values are very small as compared to the size of items, it is represented by false baseline charts. Let me explain what is that false baseline. Now, if I represent in the graph, let's say, the date of birth of people sitting in the class. So, what should be my starting point in the graph? In graph, I'll always start with 0. That is origin. Graph is always started with 0. And now we are in the year 2022. That will be the last point. Now people would be born, I mean, sitting here might be in the year of 2020, or maybe in the year of 2021, or maybe in the year of 1999. You will be around that that age. Anybody born in the year 0? So these things will be waste, right? This area. The starting at least should be 1980 something. At least maybe 1990 only makes sense. So we don't start with 0. Better we start with 1990, because below that or before that is having no data point. So that's what is called as false baseline. Base is supposed to be 0, but making it 0 is not appropriate. It's very small as compared to the total size. So we ignore that 0 and we start from the appropriate 9, that is 1990. That is why it is called as false baseline for proper presentation. Okay, so the false baseline is the answer. To draw histogram, frequency distribution should be exclusive type. So what is exclusive? I'll just explain once more. So when I write it less 10 to 20, 20 to 30, 30 to 40. So if I say 30, it is included in the last interval. That is included in the lower one, not in the upper one. It includes lower limits, not the upper limit. It excludes upper limit. So it is called as exclusive class type. And not only to draw histogram. Anything in statistics, we always need exclusive type. Even we go for median calculation, any correlation, regression calculation, we always need in statistics exclusive type. So inclusive type is not used in any of the tabular or any statistical calculations. So exclusive type is appropriate. For the data frequency distribution, if the class length is 5, the number of class intervals will be. Okay, so for this, we will have to look for some small formula kind of thing, logical only, but if you want to remember like a formula, you can remember. It is, okay, first we'll calculate the range. That is the starting to end points. Highest value is 71. 73 is the highest one. And the lowest is 44. So range is 29. So when I build the interval, the starting to end point, that range will be 29 or more. And they said the class length is 5. And so if length is how many number of rows? So total range is 29, number of length is 5. So class interval, or if you want to use the formula, you can do like this. The length multiplied by number of class intervals, number of rows, number of class intervals will give you range. So length is given as 5. We need to calculate number of class interval. Range is 29. So when you take 5 to right side, it will go denominator. So number of class intervals 29 divided by 5. You get 5.8, but we can't have 5.8, so round it off. We get 6. So 6 number of intervals. Okay, next. There were 200 employees in an office which 150 were married. Total male employees 160, out of which 120 married. What was the number of female unmarried employees? So let's convert this into a tabular format. So two varieties are there. One is married, unmarried, and the other variety is male and female. So you can have like male and female, and column wise I can make it as married and unmarried and total. There were 200 employees in office, so total is 200. 150 were married, so this total is 150. Unmarried total becomes 50. 160 were male employees, so male is 160, so female therefore will be 40. And what was the number of female? Okay, 120 were married out of 160. Out of 160, 120 were married. So 120 were married. So 160 minus 120 is 40. 150 minus 120 is 30. 50 minus 40 is 10. So they're asking unmarried female. So female unmarried, that is 10. So when they give you sentence like this, you convert this into a tabular format. Becomes easy for you to calculate anything they ask. So write the table slowly and see if you have any doubts. Okay, next one. The following data relates to marks of group of students. How many students have got less than 50%? Please read it carefully. This is more than 70, more than 60 means this is cumulative frequency. And they asked how many got less than 50%. So for that you see how many got more than 50%. More than 50% is 40 students, and totally there are, don't add all the numbers, the last number becomes the total. So 100 students, out of 100, 40 students have got more than 50%, so remaining 100 minus 40, that is 60 students. You can calculate the frequency first. That is, you start with this as 7, then 18 minus 7 as 11, 40 minus 18 as 22. Like this you calculate, then any person who scores less than 50, I think you will get 3 numbers to be added up. Slightly longer method. The short method I went for this. More than 50% is 40. Less than 50% will be remaining people. 100 minus 40. 100 minus 40. 60. Okay, so this is about statistical description of data, I mean basics of statistics. Okay, so let's go for the next chapter. Statistical description of data is done. Measures of central tendency and dispersion. So this measures of central tendency is also called as the concentration of values, because when we have many numbers, we need one number. That one number is central tendency. So you know, you are traveling from home to class or college. Someday it might take 45 minutes, someday it might take 30 minutes. So how do you decide that I have to leave at this point only? Again, you go by on an average. Someday it might be 1 hour also, someday it might be 30 minutes also. I'll go with average. That average is what is called as central tendency. But how different the values are, that is variation. We have one more concept, that is measures of dispersion, that measures the variation. Let's go for this central tendency. We have mean. In that also we have 3 methods: arithmetic mean, geometric mean, harmonic mean. Arithmetic mean used in general. Popular one is called as arithmetic mean only. Geometric mean is used for ratios. Harmonic mean is used for calculation of speed, distance problems. So arithmetic mean formula is given by summation x divided by n, or we call it as also x bar. Arithmetic mean, we use the short form x bar. X bar is summation x divided by n. Summation, this symbol means add all the values, and x means individual observations. So arithmetic mean, we say x bar equals summation x divided by n for number of observations, sum of observations by number of observations. And one small doubt, I don't know whether you get those doubts. Why should we assume always in mathematics x? Why not z? See, in English, first alphabet is A. Then we should assume A. Or we are finding out something. Finding means last alphabet. Last alphabet should be Z. Why X in between? I think those doubts and all we don't ask. I also been figuring it out. I also don't know the answer clearly, but my thinking, my assumption maybe is this: the person who invented mathematics had lot of X in his life. So till today we are finding X. So whenever we don't know something, find X. Let's assume X. So still we are finding X. We have not found it, and maybe that's why some people don't like mathematics. Because when we say assume X, no, you remember your X. So you go to the personal level, emotional level, so people will get weakened in the studies. For some people will not get, they are good in mathematics, but for some people they remember. And for some people, slideshow only may start, X1, X2, X3 like that. So again, they become more personal, emotional. And maybe they go to bar, so they made it as X bars, as summation X by N. And we don't know why all these things happen. So after X, we assume always Y. Let's assume Y. So X and Y are the most famous variables. So logically, I don't know. But sometimes you have to think like this when we say think out of the box. Even in accounts, for debit, we say short form is DR. For credit, short form is CR. For credit, it makes sense. CR, R is there. For debit, where R coming from? Oh, for credit, CR, okay, CREDT, CR, I'll take it and make a shortcut. For debit, where is R? D is there, debit. Where is R? DR. There is answer, but I won't tell you because not required for exam. But try to think on those lines. Only when you can think, ask questions, you will also explore more. Anyway, tell the answer. It's because the root of English is from Latin. Actually, it's not debit, it is debire, it's not credit, it's credire. So debire, DR, credire, DR, CR. That is the language is derived from the Latin word there, and that continues. So it may, always you will have some legacy, some history. But when you think on those lines, subject also becomes more meaningful. Rather than just by hearting, those things will always be helpful. But anyway, so group data is summation X by N. For ungrouped data, we also take frequency, it's capital N. X bar, we write it as summation Fx by capital N. We take frequency also into consideration because frequency represents the repetitions. Then we have combined mean. So if you have two sets of data, that is combined mean, we have X bar 1, that is one set X bar mean, N1 number of observations, plus X bar 2, the second set, its mean, N2 number of observations, X bar 1 N1, X bar 2 N2 divided by total number of observations N1 plus N2. For weighted average, we simply multiplied by weights. So it's actually same as grouped mean only. In grouped mean, we multiplied by frequency. In weighted average, we multiplied by weights. When something is more important, we assign weights. Weights and frequency play a same role. Then some properties are there, which is also very important. Summation X minus X bar equal to 0. X minus X bar is called as deviations. X minus X bar sum is called as sum of deviations. And sum of deviation from mean is always 0. And if I square it, it is always minimum as compared to median or mode. So summation X minus X bar, sum of deviation is always 0. And square of deviation is minimum as compared to others. So examination question, they'll ask you like this. Deviation from mean may be positive, may be negative, 0, or any of the above. Which one is the answer? That's why you get marks also 0. The answer is any of the above. I did not ask sum of deviation, I just asked deviations. The deviations X minus X bar, it can be any of these three numbers. Sum of deviation will be 0. So read the question carefully. The summation symbol is there, then only it is 0. But individually, the number can be positive, negative, 0. Any number can happen. Sum of deviation is 0. Be careful about it. Especially in English, always be careful when you interpret. And you have to interpret based on the context also. You know, they say behind every successful man, there is woman. So if you want more success, not more women, you need to work hard. So always in English, try to interpret. Don't go with the sentence as and when they have given. So person who buy is called as buyer. The person who sell is called as seller. The person who takes commission is called not commissioner, broker or middleman, agent. So don't go with the flow. So read English, the sentence carefully. Okay, so geometric mean is multiplying all the numbers and taking an nth root. So if 5 numbers are there, multiply all the 5 numbers and take the 5th root. Useful for ratios, growth, percentages, sales growth, population growth, geometric mean is appropriate. Harmonic mean, that is applicable for speed distance formula. It's called as a reciprocal of arithmetic mean of reciprocals. Formula wise, we say n divided by sum of it, 1 by x1, 1 by x2, 1 by x3. Only if 2 observations are there, we have one shortcut, that is 2ab by a plus b. Then median is called as the middlemost observation. So ungrouped data, we use the formula n plus 1 by 2, and please keep it in mind, the formula is not n plus 1 by 2. N plus 1 by 2 give you only the positional value, the position, 5th position, 6th position, the middlemost value, that is median. This formula only give you the position, not the value in it. The median is always the middlemost value. This formula will give you the position in which the value has to be taken. N plus 1 by 2. In an array means arranged from lowest to highest. For a group data, that formula is not very important from exam point of view, but quickly we look at it. For a group data, it is L plus n by 2 minus m by f into c. L for lower limits, C for class limits, F for frequency, n by 2, number observation by 2, m is the previous cumulative frequency. And how do you find out the median class? Wherever the 50%, n by 2 is crossed. So we'll always have 3 columns. One is class interval, then we'll have frequency, then we'll also have cumulative frequency, means you keep adding up. And whenever this cumulative frequency crosses n by 2, for example, if there are 100 students, 100 by 2 means you get 50. Wherever that 50 is crossed, that class is called as median class. And based on median class, you derive L value, F, C, and M. But from exam point, that is less important. So we'll keep it aside for the time being. Mode is the most frequently repeated ones. So no formula as such. Ungrouped data is wherever most frequent. For a group data, we have formula L, lower limits, C, class limit, F0, F1, F2. That is F0 is previous to the modal class frequency. F1 is the frequency of modal class. F2 is the next frequency of the modal class. Modal class means wherever the frequency is highest. Then other positional measures, this is just like median. Median divides into 2 equal parts, that's median. If you divide into 4 equal parts, it's called as quartiles. 10 equal parts deciles, 8 equal part octiles, 100 equal parts percentiles. So how many quartiles should be there? There are 3 quartiles. 4 parts, not 4 quartiles. Quartiles is the divider. So median divides into 2 parts. So we don't say median, there are 2 medians. 1 median, 2 parts. Like that. In quartiles, we have 3 quarters. That is, if you have a box, the box will have 3 dividers. Q1, Q2, Q3. So that is quartile 1, quartile 2, quartile 3. And it has 4 parts. It is not Q1, Q2, Q3, Q4. The dividers are called as quartiles. And each part will have 25%. That is quartiles, 4 equal parts. Deciles means that is 10 equal parts. There will be 9 deciles. Octiles means 8 equal parts. So 7 octiles will be there. Percentiles means 100 equal parts. So you will have 99 percentile. So when I say your percentile is 98, It means there are 2% of the people below you. That's what the percentile 98 means. That is, you are at the 98th position. So, beyond you, there are 2% of the people. Below you, there are 98% of the people. Or if I tell you, here only Q1, Q2, Q3. So, if I say Q3 below, you are having 75%, and Q3 above, they are having 25%. So, that's what the quartile, decile, octile interpretation is. And formula wise, for median, we divide by 2. N plus 1 divided by 2, for quartiles divide by 4, deciles divide by 10, octiles divide by 8, percentiles divide by 100, and corresponding number I multiply. See, for example, I need a third octile, that is O3. We first will do n plus 1 by 8, then third octile is there, so I will multiply it by 3. If it is seventh octile, I will multiply it by 7, and so on. So if I need a third decile, D3, so first I will do n plus 1 by 10, then third one I need, so I multiply it by 3. So that's how we get the decile positions across different measures. Okay, so this is the summary of measures of central tendency. Okay, let's go for measures of dispersion. Then I'll give time for you to read through it. So dispersion measures the variation or scatterness. Broadly, we have 4 methods, or within that we have 2 methods. One is absolute method and other is relative measure. Absolute measure is having units, marks, marks or rupees, kilometers. When you have units, it's absolute measure. When you don't have units, that is called as relative measure. Why it is? Because when it is units, you can't compare. So which one is higher, 1 kilometer or 30 grams? We can't compare. One is kilometer, other is grams, not comparable. That's what happens in the absolute measure. But relative measure I can compare, it is expressed in percentages. So, and that is why the relative measure is also used for comparison. Absolute measure cannot be used for comparison. Whenever the word relative comes, the word comparison also comes. Not only in subject, in life also. Whenever relative comes, be ready for comparisons. That will always be there. That you can't avoid. Absolute measure, we have one is range, that is highest minus lowest, and coefficient of range, that is expressed in percentages, highest minus least by highest plus least into 100. We have quartile range, highest quartile minus lowest quartile, Q3 minus Q1, or semi-interquartile range, that is half of it, that is also called as quartile deviation. And coefficient of quartile deviation, similarly Q3 minus Q1 by Q3 plus Q1 into 100. Then we have mean deviation, x minus the average. The average may be mean, average may be median or mode, and we take these absolute numbers, means we ignore the minus numbers. It is called as sum of absolute deviations, and divide by n. And most important one being standard deviation, which is sum of x minus x bar whole square by n. That is deviation, then we square it, then we take an average. Or one more alternative formula is also there, summation x square by n minus summation x by n the whole square, then square root. Corresponding coefficients for mean deviation by average. For star deviation, it is star deviation by mean, because only mean is used. And coefficient of variation means higher the coefficient of variation, lesser is the consistency, because when variation is high, consistency will be less. And this standard deviation square is also called as variance, or variance square root is called as standard deviation. That also you should be aware of it. And all these measures are always positive, because we take only highest minus least, we ignore negative signs, we square it here. So all these numbers are always positive. One important property is there, and after that we'll go for for you to read the summary. That's one important concept. Let me do it slowly. Please observe here. Most frequently asked from exam point of view. Change of origin and change of scale. All observations are added or subtracted by same number. That's called as origin. Or all observations are multiplied or divided, and that's called as scale. And what happens to central tendency? Central tendency will change. For example, if the numbers are 2, 3, 4, if I add everything by 10, what will happen? I get 12, 13, 14. What is average of 2, 3, 4? Simple one. 2 plus 3 plus 4 divided by 3, I'll get 3. And 12 plus 13 plus 14 divided by 3, I get 13. You see that numbers are increased. My average also increased. But what happens to range? The range is highest minus least, 4 minus 2, which is 2, and 14 minus 12, and that is also 2. So when I add, the arithmetic mean changed, but the range did not change. So we say central tendency change in case of origin, but dispersion does not change, remains same when in case of scale. So in case of origin, that is added or subtracted. But if you multiply, central tendency also changes, dispersion also changes. So what we say is like this: central tendency is dependent on change of origin, whereas dispersion is independent of origin. Central tendency is dependent, dispersion is dependent on change of scale. And what does it mean? When they give you equation, we should ignore the constant. So they give you like this: y equals 2x plus 3, and they'll tell you x bar equals to 1. What is y bar? You just simply substitute. In place of x, if you substitute as 1, so 2 into 1 plus 3, you get the answer as 5. That is what is y bar. But if they tell you standard deviation of x equal to 1, this is where you have to be careful. When I substitute standard deviation, this plus 3 I'll have to ignore. Plus 3 means all the observations are added by constant, and standard deviation does not change. So when they give you equation for arithmetic mean, I simply substitute. For any measures of central tendency, substitute. But for dispersion, I should ignore the constant. That's what I mean by this word. When the equation is given for dispersion, ignore the constant. Plus 3, you will ignore it. And even negative sign also will ignore, because dispersion is always positive. So take a look at this chart as well as the summary what I have given. Just go to the formulas and see if you require any explanation. I think from exam point of view, this chapter will also come for the highest number of marks. So we also have some 25 questions to discuss in class. Which one? Which one? An example, you mean that change of origin, change of scale. Okay. So the concept is the change of origin, which means when all the observations are added or subtracted. Scale means all the observations are multiplied. So if they give you equation y equals 2x plus 1, this expression means all the observations are added by 1. Plus 1 means added by 1, and 2x means all the observations are multiplied by 2. This is for individual observations. Now when I come to the mean y bar, I can simply write it as 2x bar plus 1. The reason being, if all the observation changes, arithmetic mean also change. But when I write it for standard deviation of y, I cannot write it as plus 1. I'll just simply write it as standard deviation of x. I don't write plus 1. The reason being, dispersion will not change when all the observations are added. So this plus 1, observations might change, but standard deviation does not change. That's why I tell you, ignore the constant in equation. So plus 1 I ignored, I simply wrote it as 2x. So in the question, if they give you as x bar is 3, so I substitute here, which is 3 into 2 plus 1, so y bar becomes 7. And if they tell you standard deviation of x is 5, then if I substitute 5, I don't do just do 5 into 2, I don't do plus 1. I simply do 5 into 2, that is answer is 10. Plus 1 is not done. For measures of central tendency, we use the equation as it is. But for dispersion, in the equation, we ignore the constants. Ignoring the constant is what important points in this chart. So go to the summary again, see if you still have any doubt in this one or any other calculations. Either in central tendency or dispersion. See if you have any doubts. Okay, no specific doubts? Okay, so let's take up problems. Maybe in that progress you might get some doubts. If the AM and HM for two numbers are 5 and 3.2 respectively, then the GM will be, there is a relationship between the three. Let me just quickly cover it. Arithmetic mean is greater than geometric mean is greater than harmonic mean. If all the observations are equal, then these three also will be equal. But distinct numbers, AM is more than GM, is more than HM, and also geometric mean formula is given by square root of arithmetic mean into harmonic mean. So geometric mean is the geometric mean between arithmetic mean and harmonic mean. It is between the two, multiply square root, you get it. So geometric mean, arithmetic mean here is 5, harmonic mean is 3.2, and you multiply, you take square root. So I think you get 16 square roots, that is 4. Geometric mean is square root of arithmetic mean and harmonic mean. Okay, next. The average salary of a group of unskilled worker is 10,000 and that of group of skilled worker is 15,000. If the combined salary is 12,000, then what is the percentage of skilled workers? So this is problem based on combined mean. So let's write that one. We have two varieties, that is skilled and unskilled, and one combined overall. So skilled, unskilled, combined. Average salary, I'll write it as X bar. Skilled is skilled worker average 15,000. Unskilled average is 10,000. And the combined is given as 12,000. And they're asking what is the percentage of skilled workers, not the number, percentage. And percentage we always express it in hundreds, percentage. So I'll call it as N, and total combined percentage I'll write it as 100. Percentage means 100. And they're asking percentage of skilled workers. So skilled workers I'll take it as X. And unskilled workers therefore will be 100 minus X, because they will be remaining. If 100 is there, if skilled worker is 70%, remaining 30% will be unskilled. So 100 minus X. And let's write the formula for combined mean. Combined mean is X bar 1, 2. Combined mean is given as X bar 1 N1 plus X bar 2 N2. Mean multiplied by number of observations, whole divided by N1 plus N2. So combined mean X bar 1, 2 is 12,000. And X bar 1, that is 15,000. And N1, that is multiplied by X. Plus X bar 2, that is unskilled workers, 10,000. Multiplied by N, in this case is 100 minus X. Whole divided by N1 plus N2. N1 is X. And N2 is 100 minus X. So X bar 1 15,000, N1 X, X bar 2 10,000, N2 100 minus X, and combined mean 12,000, and Actually, I can write 100 only in the denominator, n1 plus n2, but I'm writing it separately. n1 is x, n2 is 100 minus x. So actually, I can cancel that x and minus x. What remains is only 100, and total is only 100. So even I could have directly written 100. Cross multiply. 12,000 into x, I mean 12,000 into 100 becomes 12 lakh. 15,000 into x is 15,000 x plus, open the brackets, 10,000 into 100, 10 lakhs minus 10,000 into x, that is 10,000 x. I just cross multiplied and open the brackets there. Now to simplify further, what we should do, all the variables should be one side, numbers should be on the other side. So the 10 lakh on the right hand side, I'll bring it to left side. So I'll write it as 12 lakh as it is, minus the 10 lakh comes to left side. So minus 10 lakhs. This 15,000x minus 10,000x, I'll simplify. 15,000 minus 10,000, that is 5,000x. I'll write 5,000x here, and 12 lakh minus 10 lakh means 2 lakh, and x therefore is 2 lakh divided by 5,000, which is 40. So this is what we required also, skilled labor, answer is 40. It is percentage, so it is 40%. Okay, hope you got the answer, 40%. There is one more method, I will do that one also, but make sure that you have completed till here. Okay, so I hope you got this one. I'll take it out, then you don't tell me show it again. I'll take it out. Okay, the shortcut is this. We have skilled labor, then we have unskilled labor. Skilled is 15,000, unskilled is 10,000, and average in between is 12,000. This is what they have given. So what you have to do is subtract, but cross subtract, in the sense you write 15,000 minus 12,000 is 3,000. Similarly, 12,000 and 10,000, the difference is 2,000. Don't write in the same place, write in the opposite place. Cross subtracts. So what is the ratio you get now? 2,000 and 3,000. So ratio is 2:3. So the percentage divide in this ratio. Percentage means 100. Ratio is 2:3. So 100 into 2 by 5. Like a profit sharing ratio. 100 divide in the ratio 2:3. So 100 into 2 by 5, you will get the answer as 40, and that's all the answer. So you cross subtract, find out the ratio, and divide the percentage in that ratio. Percentage is 100, so divide in the ratio of 2:3. So that is a shortcut you can use whenever they ask this type of problem. Okay, so next one. Find HM of 20 and 30. So we can do it in two ways. One, using the base formula, harmonic mean is given by n divided by 1 by x1 plus 1 by x2 and so on. In this case, there are two observations, 20 and 30. So I'll take it as n is 2 divided by 20 and 30. So 1 by 20 plus 1 by 30. So 1 by 20 means I think 0.05 and 1 by 30 is 0.033 I think. I mean it's a recurring one, so I'll take 4 decimals. So 1 divided by 0.0833. So you get 24. So we can use another formula, which is 2ab divided by a plus b. This formula you can use only when there are two observations, that you keep it in mind. So 2ab, so 2 into 20 into 30 divided by 20 plus 30. So 2 into 20, 40, 40 into 30 is 1200 by 30 plus 20 is 50. Hope you get the same answer, 24. So you can also use that formula 2ab by a plus b, but be careful, that formula can be used only if in case of two observations. But if there are three observations, I have to stick to the base formula. This also actually we can do directly in calculator if you use that technique what we used earlier. Let's try. So once you have done this, let's go for this, but make sure that if you have any doubts in these calculations, get clarified. Okay. So let's try in the calculator now. Start fresh, clear the calculator memory on MRC and all. Then do this. 1 by 20 equal to m plus 1 by 30 equal to m plus 2 divided by MRC equals. So you get the answer 24 directly. You don't have to write down anywhere. I'll tell once more. This will help you in exam. If there are multiple values like this, understand it with the logic. Clear the calculator memory. Start fresh. MRC 2 times on everything. Clear everything. Start fresh. Understand logically and write. See, we are calculating this one. 1 by 20 equal to m plus. We are keeping it in calculator memory. Then 1 by 30 equal to m plus. So what happened so far? Whatever we calculated, we have added to the calculator memory. So 1 by 20 is also in calculator memory. 1 by 30 got added to that number, and that's what we wanted also, because it is plus. So that got added. That is there in calculator memory. And what we require, listen to me, then you do it. 2 divided by this number, and denominator is in calculator memory. And how do we extract calculator memory? By pressing MRC. So what should I do? 2, I type the numerator, divided by what is in the calculator memory, MRC, equals. So understand with the logic, so that if for different problem you will be able to do it. Try it once more for quick understanding. Clear the calculator memory, start fresh. 1 by 20 equal to m plus, 1 by 30 equal to m plus, 2 divided by MRC equals. Okay, we'll just solve one more problem. After that, we'll go to next problem. Okay, we'll solve the next problem. Mode can be obtained from histogram. Mode can be obtained from histogram. If it is median, we can obtain from ogive curves. If it is mean, mean can be obtained from, mode can be from histogram, median can be from ogive curves, but mean can be obtained from only calculator, no graph. Mean cannot be obtained graphically. Just keep that in mind. Anyway, so for this, answer is B. Okay, this question we'll take it after the break. 10:50 now. We'll take a break of 15 minutes. 11:05 we'll meet. 15 minutes. Okay, next one. Variance of 3584 is, variance is square of standard deviation. So let's compute standard deviation first. We'll have one column for x, 3584. And actually the second formula is more faster, so let's use that one. This formula, let me write it. Standard deviation equals square root of summation x square by n minus summation x by n whole square. So I need two columns, one for x, one for x square. Let me do the total of x column. That is, I think 8, 8, 16 plus 4, 20. Let's do x square column. 3 square is 9, 5 square 25, 8 square 64, 4 square 16. 80 plus 105 plus 9, 114. So you get 114. So this 20 is total of x. So we can say summation x. This 114 is total of x square. So we can say summation x square. N number of observations, which is equal to 4. So let's substitute. Standard deviation equals summation x square, which is 114 by n, which is number of observations 4, minus summation x 20 by 4 whole square and square root. So 114 by 4, you get 28.5, and 20 by 4 is 5 square. 5 square is 25. So square root of 3.5. $1.87. But they are not asking standard deviation, they are asking variance. So variance is standard deviation square. So standard deviation square is variance. I'm writing at the top. That is 1.87 square. Which is 3.5 only. In fact, if I don't do the square root, what I get is variance only. We have done the square root, then we have squared it. Or if you don't take the square root, the result is called as variance. But anyway, let's keep to the same process. You calculate the standard deviation, then square it. What you get is variance. No, that's not. Both should give same answer. Second formula is no. You should get the same answer. We'll try the second one also. Second one is faster, so we do that from exam point of view. But first method also should give you the same answer. Okay, I'll tell you why. One more reason second method is faster. Okay, hope you got this answer. 1.87 square 3.5. Now here we have calculated this whole process. This can be simplified if you make use of calculator efficiently. So let's do this. Do it in the calculator. Start fresh. Clear the calculator memory on MRC, everything. Start fresh. 114 divided by 4 equal to m plus 20 by 4 into equals m minus MRC square root. You should get 1.87. Of course, square of this we get 3.5, that is there. Okay, so let me explain the logic also, how we calculate this. So you start once more, start fresh, clear the calculator memory, on, clear. We are calculating this first, 114 divided by 4 equal to m plus. So what is in the calculator memory now is 28.5. Next we calculate the second part, 20 by 4. So what you calculated, you get the answer as 5. You would have seen that is there in the calculator. But what I need is square. So how do I calculate square? Into equals. So when I do into equals, I get the square of it. So you would have got 25. Now this I need to subtract. So I press m minus. So when I pressed m minus, this number got subtracted from 28.5. So calculator memory has 3.5. But to see the calculator memory, you press MRC. You will find 3.5. Then do you take a square root? You get 1.87. So try it once more for practice. Along with the logic to it, clear the calculator memory. 114 divided by 4 equal to m plus 20 by 4 into equals m minus MRC square root. 1.87 you will get, but ensure that you are able to understand it correctly and then calculate it. This is how you should save time in exams. So rather than understanding your friend, if you can understand the calculator, calculator will help you back in examination. Your friend may not, your calculator will. So make calculator your friend. Just try to understand the functions behind it, you will be able to calculate automatically. Like when you press M plus, how the calculator is functioning, when to press M minus. So those things, if you can understand, calculation becomes faster. Now second part, now you understood from the first step, we can go to the last step without any calculations in between. But still this requires two tables to be written, and we can avoid writing these two tables also. How? Now this first one table is very easy. 3 plus 5 plus 8 plus 4, you get the total 20. First column is easy. Second column, what we have to do? X square means each number is squared, and then we have to do the total. So what we can do? We can take help of the GT function. So try the calculator once. What you have to do is each number you have to square it. So and how to do a square? The faster, you just have to press into equals. So try it out. 3 into equals 5 into equals 8 into equals 4 into equals. At the end, GT. If we don't have GT, my answer is straightforward. Have a calculator with GT. Yes, you can do with M plus. We will do that also. You will get the answer, but I recommend have a calculator because that will save time and avoid confusion. So we'll do it once more with GT, then I'll do with M plus also once. So 3 into equals, 5 into equals, 8 into equals, 4 into equals, GT. You get 114. Now with M plus, again start fresh, clear the calculator memory. 3 into equals M plus. 5 into equals M plus. 8 into equals M plus. 4 into equals M plus. At the end, MRC. You still find 114. So you can do this, but the thing is, you should remember every time you have to keep pressing M plus, M plus. So in the examination tension, you might miss one, so you would start fresh again once more. So instead of becoming a shortcut, it might become a burden later. So that one, of course, you are confident you can do it, but GT is more safer. You have to keep calculating the number, and GT will automatically do the total for that reason. Okay, so even if you for first method you get the same answer, but the shortcuts cannot be applied in first methods, and therefore I choose the second method for faster calculations in examination. Okay, so let's go further. Variance of x is 23. Find the variance of 2x plus 10. Okay, this 2x plus 10, let me make it an equation, which is y equals 2x plus 10. Instead of just 2x plus 10, I'll make it as equation. And what they've given is variance. And you know, you can calculate standard deviation as variance. What they've given, okay, let's write what they've given also. Variance is 23. And I cannot directly simplify with variance, so I'll convert it to standard deviation. Standard deviation is square root of variance. So 23 square root. 4.7958. Let's, yeah, 4.79. 4.79. Okay, this is standard deviation of x, but I need not x, I need for y. So what I'm going to do, this x value I will substitute in the place of x. But what will I do? One more thing is this plus 10 I will ignore, being independent of change of origin. I will not ignore like this if it is arithmetic mean. I do only for dispersion. So ignore the constant. So ignore the plus 10 and then substitute. So standard deviation of y equals 2 into 4.79 plus 10, don't do it. 9.5. 9.58. Okay, but I don't require standard deviation, I need variance, so I'm going to square this. Standard deviation square 9.58 square 91.77, you can round it off 92. Okay, there is one more shortcut for this. Let me quickly cover it also. So in the equation we have 2x plus 10, and you know that 10 plus 10 should be ignored because it is measures of dispersion. So what we have is 2x, but only one thing you keep it in mind. We are calculating variance, and variance is always a square. So what do? You substitute this number, but the coefficient what is there, you square it. So we have 2, coefficient of 2 is, square of 2 is 4, and substitute will be 23. You get the answer directly 92. So whenever you have variance, the coefficients must be squared because variance means square for that reason. I'm showing both the methods, shortcut as well as regular. Apply the shortcuts carefully, but it will save time, but you have to practice it. So all the shortcuts are subject to conceptual risk. Please understand the shortcuts carefully before applying exam. If some shortcuts goes wrong or applied wrongly, I'm not responsible. I'm showing you both the regular ones as well as the shortcut ones. So for variance, you have to square the coefficient. Okay, next. There were 50 students in class, 10 failed, whose average marks is 2.5 and total marks were 281. Find the average of students who passed. Okay, total is 50 students in class. So, okay, total 50 students. Out of it 10 failed. Okay, total marks is 281. So total is 281. And this will comprise of students who passed as well as student who failed. And they have given 10 failed whose average marks is 2.5. So each person is 2.5. So total of persons who failed will be 10 into 2.5. Each person is 2.5, 10 people are there. So 25. So what will be the marks of past students? 281 minus 25. 256. Don't select the answer as 256 because what I got is total marks. But what they're asking is average. So you divide by number of students who passed, not the total, only who passed. 50 students were there, 10 failed. So those who passed will be 40. 6.4. If they ask total marks of students, then it is 256. But they have asked average marks. So you should divide by not total students, just divide by students who passed. So 256 by 40. So you can see we are not using any formula here. So many times without formula also you'll get the answers. Okay, next. Quartiles can be found through ogive curves. Median can be obtained. Quartiles can be obtained. Percentiles, octiles, deciles. All positional measures can be obtained in ogive curves. All positional measures. Median is also a positional measure. Quartile also a positional measure. Deciles, percentiles, octiles, everything can be obtained through this cumulative frequency graphs, ogive curves. Average of two number is 20 and the standard deviation is 5. Find the two numbers. Now this we can solve. We'll assume the number as A and B and then we can use the formula simplify. But we'll go by options method faster. And for average of two numbers, I understand the two numbers x plus y divided by 2. Standard deviation, how do we calculate? Yeah, we'll multiply. Only two numbers are there. Okay, we can go for it. So let's calculate x bar and let's calculate standard deviation. Now, standard deviation formula, we have to do a big one. X square by n minus x by n whole square. But we'll use one shortcut is there. A standard deviation only when there are two numbers. Not every time. Only when there are two numbers, standard deviation is half of range. Only when there are two numbers, this shortcut can be used. So we have two numbers only, so I can make use of this. So for all the functions, you calculate average, and for all the options, you calculate the standard deviation. So for option A, average 15 plus 25 by 2. That is 20, and standard deviation half of range, that is 25 minus 15 by 2, which is 5. So that's what you got the answer, I think. Average is 20, standard deviation is 5, so answer is matching. So option A is the answer. Let's try for B also, just for confirmation. 30 and 40, so 30 plus 40 divided by 2. You get as 35, and half of range 40 minus 30 divided by 2, you get 5. 5 you get, but 35 is not the answer. So option B is not. Like that you can try for C also. So option A fits. So standard deviation for two observations, you can use this shortcut, half of range. Only when there are two observations. Okay, next. Geometric mean of 468 is. Okay, geometric mean is given by, we have to multiply x1, x2, x3, then we take to the power of 1 by n. So x1, x2, x3, we have 4, 6, 8 to the power of 1 by n. So 3 observations are there to the power of 1 by 3. So 4, 6, 8, 192 to the power of 1 by 3. Okay. Now cube root cannot be calculated easily in the calculator. So what I can do is I'll go by the options method. Each option I'll cube it. I should get 192. So I have option A 4.77, cube it. I mean approximately, not exactly, will not get it. So 4.77 cube. So 4.77 into equals. I think 108 something. 5.32 cube. 150, that is also not there. 6.14 cube. 231 something, that is also not there. 5.77 cube. I think you get 192 there. So 5.77 cube is the answer. So when it is 3 numbers, you calculate cube, that answer should come. That is options method. If it is 4 to the power of 4 and so on. One more method is there, that is taking log on both sides. Will not do that method, because whenever I say take log, people will take next question. They don't even look for log solution, so will not worry. Anyway, options will be there in the exam. Let's make use of it. Okay, there is one more method. We'll try that one. So what we need is 192 to the power of 1 by 3. So that will calculate in the calculator, the regular calculator only. So I'll take this out. So type 192. You press square root 15 times. Then minus 1 into 1 by 3 plus 1 after pressing 15 times, minus 1 into 1 by 3, then plus 1. This last step, be careful. I'll explain once, then you do it. You should do into equals like that 15 times, not just equals. You press into equals, repeat that 15 times. You will get 5.77. So even regular calculator you can do, only changes it is the cube. So I've applied 1 by 3. If it is 5 observations are there, I'll do 1 by 5. All other calculations remain same. If it is 8 observations, I'll do 1 by 8. 7 observations, I'll do 1 by 7. If there are 2 observations, I know 1 by 2, but square root only gives the answer. No, why to follow this process? If only 2 observations are there, multiply the 2 number and take the square root. You don't have to follow this long methods. If it is 5 observations are there, I'll take it as into 1 by 5. Other calculations remain same, only this will change. To the power of 1 by 3, only that will change. We have done 15 times. Some people do 12 times. That is also fine. I think 15 times should give you a reasonable answer. Okay, next. Hope you have written down this also, this shortcuts. Okay, next. In a class of 11 students, 3 students who failed in a test, 8 students passed secured numbers respectively. What will be the median marks of students? For the median, we always need first an array arrangement from lowest to highest. But the problem is They said 3 students failed, but their marks not given. But we don't have to worry because they would have got definitely lower marks only. So let's just call it as something like x1, x2, x3. Because when I start an array, it has to be from lowest to highest. So I'll start with those 3 people only. Because failed means would have got a lower marks. So do not ignore those 3 students. Some people, what they do, they start from 10. No, 10 students is those who are passed, but 3 students below them. So that also should be considered. Then you start array, lowest is 10, 11, 12, 13 is not there, 14, 15, 24, 26. So 11 is there, 1, 2, 3, 20 is there. Okay. So 20, 24, 26. 11 is there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 students are there. So median is n plus 1 divided by 2. So 11 students are there. 11 plus 1 by 2, you get 6. Remember, 6 is not the median. This is only give you the position. So we have to go to 6th position and don't start from 10. Start from the lowest. So x1, x2, x3, 3, 4, 5, 6. So 6th one is 12. So median is 12. What if had you got 6.5? Then 6th plus 7th divided by 2. We take the average. What if it is 6.25? 6.5 is easy. 6 plus 7th by 2. If it is 6.25? Okay, first of all, you cannot get 6.25. See, because it is number of observations, no. Either it will be full number or 0.5 will come. Because you're dividing by 2. How 0.25 will come? Answer will be either 6 or 6.5 or 7 or 7.5 or 8. You will never have a situation of 0.25 median. But 0.25 can come in case of quartiles. I divide by 4. In that case it can come. So if it is 0.25, what you should do is, you do the 6th observation. Then for 0.25, I take 0.25 of difference between next 2 observations. 7th minus 6th. That 0.25 I'll take it in case it is decimal. Anyway, in this problem it's not there. So 12, option A. Okay, next. When all observation with equal frequency dash does not exist. Mode does not exist, because if all are equal frequency, we don't know the highest one. When we don't know the highest one, we can't choose one. So we have no mode. Now which number? Then you'll take all the numbers. If all observation occur with equal frequency, 10 observations are there, that is 3 times. 12 is 3 times. 17 3 times. 21 3 times. So we say 4 modes. We can say 4 observations only is there. So when all observations are there with equal frequency, modes does not exist. Don't worry, calculator and all will fall. It's a very natural phenomenon. Calculator will fall, book will fall, pen will fall. Sometimes persons also will fall. As long as things are not falling on me, I am safe. I'll continue. Okay, one more question similar to this I'll ask. See if you can answer. Which observation compulsorily requires frequency? Mean, median, mode, none of this. Which compulsorily requires frequency? Without frequency I cannot calculate. It is modes. For median, with frequency also we can do, without also we can do. But for mode, it cannot, because mode is highest frequency one. If I don't know frequency, we cannot calculate mode. And mode also is that there can be multiple mode, there can be no mode, there can be bimodal, because modal is just about the number of times it is repeated. So easy to calculate but inconsistent. Okay. Next, arithmetic mean is independent of scale, origin, both, none of this. It is none of this because arithmetic mean is dependent on both of this. It's not independent, it is dependent. So it changes. It's not independent of scale also, not independent of origin also. So it's none of this. Arithmetic mean is dependent on both. Geometric mean is better than others when the ratios and percentages are given. For growth, the price increase, population growth, whenever we talk about the growth ratios, geometric mean is appropriate. Interquartile range is half of quartile deviation, double of quartile deviation. No, you never answer based on my reaction. Always apply your logic. Okay, quartile deviation is given by half of quartile range. Means Q3 minus Q1 is the quartile range. So Q3 minus Q1, this is going to be, if they cross multiply, it will be 2 times quartile deviation. So interquartile range is double quartile deviation. Quartile deviation is half, but quartile range is 2 times quartile deviation, double. The equation of a line is given, mean deviation is about y is given, what is mean deviation about x, about mean. Okay, let's write the equation. 5x plus 2y equals 17, and they're talking about mean deviation, and mean deviation means we will ignore the constants independent of origin, and they have given y is 5. So in place of y, we'll write it as 5. So 5x plus 2 into 5 is 10 equals 0. 10 goes to right side. So 5x is minus 10. X is minus 10 by 5 minus 2. Ignore the constant being measures of dispersion independent of origin. Then you substitute in place of y. They said y, mean deviation of y is 5. So in place of y, we have taken as 5, and 5 into 2 is 10. Right side become minus 10. Then divide by 5 minus 2. But one more thing to be careful, the answer is not minus 2, the answer is plus 2. The reason being, mean deviation cannot be negative. The formula for mean deviation is, if you remember, x minus x bar, we take modulus divided by n. We always ignore the minus sign. Not only this one, range, quartile deviation, mean deviation, and star deviation. The 4 measures of dispersion cannot be negative. Why it cannot be negative? Range is highest minus least. It has to be positive number. And quartile deviation is Q3 minus Q1, and Q3 is always more than Q1. Answer cannot be negative. For mean deviation, we ignore the minus signs. It cannot be negative. For standard deviation, we square it. And when you square a number, negative also becomes positive. So measures of dispersion, that is range, quartile deviation, mean deviation, and standard deviation. These 4 always positive. Even if the answer is negative, option what you have to select is positive. Range, quartile deviation, mean deviation, standard deviation, always positive. Mean and SD of x is 50 and 5 respectively. Find the mean and SD of x minus 50 by 5. Okay, what they have given mean, that is x bar is 50, and the standard deviation, I'll write like this, sigma x is 5. This is given. But what we need is x minus 50 by 5. Let me call by one variable. Y equals x minus 50 by 5. Instead of just calling it as x minus 50 by 5, I'm just calling it as one variable, y equals. And what we should do, when I say x minus 50 by 5, it means what? All the observations are subtracted by 50 and divided by 5. And subtract by 50 means change of origin, and divide by 5 means change of scale. When you add or subtract, it's origin. When you multiply, divide, it is scale. Now when I talk about x bar, I mean I'll write as y bar. Mean is simply substitution. You don't have to do any other calculation. So in place of x, I will take it as 50. Simply substitute 50 minus 50 by 5, that is 0. For mean, simple substitution. But for standard deviation, we should ignore the constant. So what is the constant here is minus 50. So when I write it x minus 50, that minus 50 I ignore, or you can write and then cancel it. Divide by 5. And standard deviation is 5. So substitute 5 by 5. You get it as 1. So 0 and 1. Mean is 0. Standard deviation is 1. That is option B. Mean is 0 and standard deviation is 1. So as I told you at the beginning also, this is the one area which is repeated the most, and they'll keep asking you in different ways. Sometimes they give you equation, sometimes they are giving you like this. Same concept, change of origin, change of scale. For mean, we substitute. For variance or for dispersion, the constant is ignored. So minus 50, I've written, I've cancelled it. That is to be ignored. Minus 50 or plus 50. Minus and plus for measures of dispersion is ignored. That one concept is repeated so many times. So 0 and 1, mean is 0, standard deviation is 1. Okay, next. If phi is subtracted from each of the observations, then its coefficient of variation is 10%. If phi is added to each item, coefficient of variation is 6. Find the coefficient of variation. This will take some time. The formula of coefficient of variation, let's write it first. Coefficient of variation, the formula is standard deviation by mean into 100. This is the basic formula. Then you apply the first sentence. If phi is subtracted from each observations, what will happen to mean x bar? Also phi will be subtracted. If mean, each observation is subtracted, mean also will get subtracted. Average is dependent. So instead of x bar, we'll write it as x bar minus 5. But what will happen to standard deviation? That will not change because that is independent of origin. So standard deviation, we will write it as standard deviation. That will not change. And its coefficient of variation is 10%. So 10%. Expressing it as percentage, that is one equation. If phi is subtracted, then if phi is added, then what we write? Phi is added means x bar plus 5. Each observation is added, mean also gets added. But standard deviation will not change. We'll keep standard deviation also, and this becomes 6%, that is 6, and 100 will continue. So we have two equations. We have to simplify. Let's divide the equation, that is for simplicity's sake. We can put one division. Divide equation by another. Here only we'll do it. So 100 and 100 gets cancelled. Standard deviation also gets cancelled. So it's 10 and 6. I'll write as 10 by 6. And what will happen to this x bar plus 5? This will go to numerator because this is denominator of denominator. That comes numerator. So we can write it as x bar plus 5 will go to numerator. And x bar minus 5 remains as it is. I'm dividing one equation by another equation. Then cross multiply. 10 into x bar, 10x bar. 10 into minus 5. That is minus 50. 6 into x bar, 6x bar, 6 into 5, 30. Now 6x bar come to left side, 10x bar minus 6x bar minus 50 goes to right side, that minus 50 becomes plus 50. So 4x bar is 80. So x bar is 80 by 4. Okay, I need some more space. So you write down till there, then I'll go to the next calculation. I substitute in one of the equation, I get standard deviation. First you write down till there. Okay, so let's go further. So I'll substitute in one of the equation. Let's say I'll do the first equation, which is 10 equals standard deviation by x bar minus 5 into 100, and x bar we got it as 20. So substitute here x bar as 20. So cross multiply, 20 minus 5 is 15. 15 into 10 is 150. I'll write 10 into 15. Standard deviation into 100. So 100 you take it left side. 10 into 15 by 100 is standard deviation. So standard deviation is 1.5. They asked coefficient of variation, that is standard deviation by mean into hundreds. Standard deviation 1.5, mean we got as 20 into 100. So 7.5. So option B. Anytime your classes is extended beyond 5? No, just asked. Some of you are already worried. And don't worry, if I have to extend, I have both the answers. If you tell that it's extended earlier, then I'll tell anyway you have the experience. And if you tell no, it's not extended, then there is always a first time. So you can always be prepared. And don't worry. When I say don't worry, that does not mean I'll not extend. I will not ask you. If I have to extend, I'll do it. But sometimes I do talk about these things, because students gets interested. When I talk about when shall we take break, how long shall we take break, what time shall we leave, people suddenly gets excited. So just to get that excitement going, I ask this question. Does not mean that we do any of those things. So how long you take the lunch break for normally? Okay, just asking. I know your excitement there. Okay, so some questions do take some extra time, but some questions also will be faster. So on an average, that's how it works out. Okay, let's go further. If all observations are increased by 10, standard deviation increased by 10, mean deviation increased by 10, quartile deviation increased by 10, or all these remains unchanged. Mean deviation increased by 10. Standard deviation increased by 10. All remains unchanged. It is all these remain unchanged. All observations are increased by 10. Standard deviation don't change. Mean deviation don't change. Quartile deviation don't change. All deviations are independent of origin. In the equation, we used to ignore constants. And here, they have asked the same question slightly differently. All observations are increased by 10. So all these remains unchanged. Mean will change, not mean deviation. The mean deviation will remain same. Mean will change. Coefficient of variation is an relative measure because we express in percentage, not in any units. If the units are there, that becomes absolute measure. So any coefficient, you can say relative measure, and that is used for comparison purpose. Which measure of dispersion is not affected by the presence of extreme observations? Extreme observations means highest and least. And affected means change. So will range gets affected? What is the formula for range? Highest minus least, which is the highest extreme values. Highest is called as extreme value, lowest is called as extreme values, the end values. So if highest changes, range also will change. Extreme observations means the highest and the lowest. What about mean deviation? How do we calculate mean deviation? Mean deviation formula is x minus x bar. We take the absolute number divided by n. X means we take 1 by 1, all observations. So extreme observation is also one of the observations. If extreme observation changes, mean deviation also will change. Similarly, standard deviation also will change, but quartile deviation does not change. The reason being, quartile deviation formula is Q3 minus Q1 divided by 2. And what is Q1? Or if you imagine the diagram method what I showed you, we divide this into total 4 parts, 3 dividers are there. So that is called as Q1, Q2, Q3. So you see Q1 is not extreme. It is at 25th percentage. Q3 is not extreme. It is 75th percentage. So if extreme observation changes, Q1 and Q3 don't change. So quartile deviation is not affected by extreme observations because they depend on Q1 and Q3, which are middle values, not extreme observations. Similarly, if they ask you about measures of dispersion, then median is not affected because median focus only on middle values. So if they ask you about measures of central tendency, then the answer will be median. Median is not affected. Okay, next. For any 2 number, HD is always half of range that I told you earlier as a shortcut. Standard deviation is half of range only when 2 numbers are given. Standard deviation is half of range. Which of the following statement is true? Median is based on observations, wrong. Median only based on middle observations. Mode is the mid value? No, mode is not the mid value. Mode is the most frequent value. Median is the second quartile? Yes, median is equal to Q2. And mode is 5th decile? No, nothing like that. So it is option C. Statement is true. Median is the second quartile because second quartile means middle. Median also means middle. Which of the following measures cannot be shown by graphical method? It is mean. Median can be obtained in ogive graphs. Mode can be in histogram. Quartiles can be in ogive graphs. Mean cannot be obtained graphically. Only algebraically is possible. Graphical mean is not possible. Mean cannot be obtained in graph. Which of the following measures is used for finding consistency between the series? Coefficient of variation. Higher the variation, lower the consistency. Coefficient of variation is the most popular one for finding consistency. Okay. So I think that's the last one on this chapter. Before we go to next chapter, I'll do a small maths puzzle. Let's see if you're able to, just understand, nothing to solve and all, just observe. Just keep it in mind, any number. For simplicity's sake, remember 2-digit number. Don't tell to your friend also. 2-digit number. Just keep it in mind. Multiply that number by 3. You can use calculator. Multiply that number by 2, whatever answer you got, and multiply that number by 3. See, for example, I would have thought, for simplicity, 10 as the answer. I mean, 10 into 3 into 2 into 3. That is 32, 60, 180. 180 I think would have got. So you would have got different numbers. Whatever the number you got, add all the 3. So if the answer is 123, you do 3 plus 2 plus 1, the answer is 6. You would have got different numbers. Then you would have got different number, I would have got different number. Then you multiply it by hundreds. Everybody would have got 900. Whichever number you start, you would have got 900. That is mathematics. Is there. You start with any number, multiplied by 3, multiplied by 2, multiplied by 3. You get some number like 123, some 3-digit, 4-digit number, whatever there, all add the numbers, you add it, digits. And then you multiply it by 100, you get 900. There I got 6. I just give an example. I would not talk about 23. You would have got different numbers. Any number you start, simplicity, you take 2-digit number, 3-digit number, you'll get the answer. Okay, so keep that curiosity going. I'll try to answer it slightly later. Easy one, not that difficult one. Small mathematical properties there. We'll come to it. Anyway, the reason why I came to that because the next chapter name is probability. So probability is one, again, a beautiful concept, which is if you apply it effectively, you definitely can make a better decision. I cannot say that probability will change your life and all, but definitely I can say that you will make a better decisions because nobody knows the future. So only 2 things are constant, which is true in world. One is you are born, that you are very sure, and you are going to die. That is you are very sure. In between those two, what happens? We don't know. Or I always say that your life is also between 2 simple letters. B and D, B for birth and D for death. In between B and D, you have one small letter called as C. That is your life. And C stands for the choices you make in life. The choices for career, the choices for friends, the choice of life partner, choice of way of lifestyle. You can say C for choice, you can say C for career, or you can say C for chartered accountancy, you can say C for the challenges. The whole of your life focus on the word C. Anyway, but if you understand probability well, I think you can make a better decisions because nobody knows about the future. So how do you make a decision about the future then? Only we make a decision based on the past. That is, in the past, it happened like this. So we assume that that is likely to be repeated. No guarantee that that will happen. So today, after the class, you go home. Is there any guarantee you will go home? No, it happened yesterday, so you think it will happen today. Until you go home, it is not guaranteed. You think it will happen, not sure. Today night you sleep. Tomorrow morning, is there a guarantee you will get up? So whenever you are getting up in the morning, always be happy that you are still alive. Every day. For that one simple reason, you should be happy, not for anything else. Just that you are still alive. the biggest reason to be alive. Anyway, so probability is that in the past, this problem or this chapter came in the exam for 5 to 6 marks. So this chapter is likely to come for 5 to 6 marks. So we don't have any other better assumption. We don't know the question paper. So you know about the history better, you can assume it will happen. That assumption is history will repeat. And you can say that may not happen, but we don't have a better solution alternative to that. Okay, probability is that important one. So probability in simple words means chance. And the formula for probability we given by number of favorable events by number of total possible events. So we also give a simple example, like we take a coin. Two possibilities are there, head and tail. So each one of them is probabilities 1 by 2, 1 out of 2. If you take a dice 1, 2, 3, 4, 5, 6, so the chance of getting any one of them is 1 by 6. So simple one. Numerator is favorable events, denominator is total possible events. Sometimes we express in ratio also. So if I express it as India winning the match against Australia, it is 5 to 6. That means 5 times we win, 6 times we lose. So if I convert this into a fraction, it will become 5 by 11, not 5 by 6. Because 5 times I win, 6 times I lose, total is 5 plus 6, 11. So when they express in ratio, m is to n, odds in favor, I'll make it as m by m plus n. I will add both. If it is odds against, that means the first number is against. So if I tell you that India will win 5 times, Australia win 6 times, so 5 times is favorable, 6 times unfavorable. But if I put it reverse, 6 times we lose and 5 times we win. So when I say odds against, the first number represents against us, not in favor. The second number is in favor. Or if I keep it in simple words, odds in favor, the first number is in favor. Odds against, the second number is in favor. And denominator, you do the sum. And this formula also you should know, that is A union B formula. It will also come in set theory. Probability of A union B is given by probability of A plus probability of B minus A intersection B. That is because intersection is in there in A also, B also. Intersection always means and. Or we can say simultaneously. Or if you draw a diagram like this, it will come in set theory also. The first one is A. Second one is the B, the common portion, which is common to both A and B, that is called as A intersection B. An entire set, either in A or in B or both, that's called as union, A union B. Then we have complement, which is outside. So probability of A union B is a total, means 1 minus A intersection B complement. That is basically means probability of either is 1 minus probability of neither. So if I say like this, if there are 2 matches, that India will win 10% of the times at least 1 match. 10% of the times at least you win 1 match. What about remaining 90% of the times? You don't win. That means you lose in both. So probability of either, we write it as 1 minus probability of neither. Probability of at least 1 is 1 minus probability of neither of them. So that is also one thing you keep it in mind. And condition probability is one thing you have to be careful. Probability of S slash M is equal to probability of S intersection M divided by probability of M. Formula wise, it looks slightly complicated, understand conceptually. When I say S slash M, it means what's the probability of S? Slash means not divided by. It means given that event has already occurred. So whatever event occurred, I'll write as slash M. So if I write as probability A slash B, which means what is the probability of A given that B has already occurred. So if you look at the Venn diagram quickly, let's say that in A, there are 60 students, in B there are 70 students, and common to both is 10. Now if I ask you, I have given you that you have selected B from section B. So it is out of how many students? I am selecting a person out of section B only. I am giving you. Section B is there are 70 students. So denominator has to be 70. Out of 70, how many belongs to A also? And that is 10. So denominator is whichever event occurred and numerator is the intersection. So remember like this, probability of S/M, that is event M has occurred, that event will come in denominator, and numerator is the intersection, S intersection M. So if I write it as probability of A/B, what will come in denominator is B, whichever event occurred, and numerator will be intersection, so probability of A intersection B. So numerator is intersection, denominator is whichever event already occurred. And sometimes they say events are independent. Independent means there is no connection, no dependency. So intersection can be calculated by multiplication. So probability of A intersection B, I can do probability of A into probability of B. I can do this only when the events are independent. They'll give you coin problem, and that is 2 to the power of n. They can give you dice problems, then the possibility is 6 to the power of n. Or they can give you number of marbles, number of balls. In those cases, we can apply the concept of combinations when you select more than one. So there are 10 marbles, you select 6. So that will become 10C6. So whenever you choose more than one, we apply the concept of combinations. And one more typical variety is there, that is based on cards. So you should know a little bit about cards. You may say I'm a very good person, I don't know about the cards and all, but from examination you should know some basic collection of it. In cards there are 26 red, 26 black. In red 2 varieties are there, that is 13 diamond, 13 heart. In black 2 varieties are there, 13 club and 13 spade. They look like this. 4 varieties of heart and diamond is red, and the spade and club, that is black. And 26 varieties are there, each color, and 13 varieties are there, each of them. So totally there are 52 cards, 13, 13, 13, 13. 52 means, 13 means I don't say it starts from 1, we start from ace. We don't have 1, we call it as ace. And 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't have 11, 12, 13, we call it as face cards. That is J, that is Jack, Q, Queen, and K for King. So it looks like this, start from ace, that is A. Then 2 to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then J, Q, K. And they are called as face cards, Jack, Queen, and King. And totally there are 52 cards. So 13 diamond, 13 hearts, 13 spade, 13 club, 26 black, and 26 red. So if they ask you the question, what is the probability of selecting a red card? Denominator you should write total events. And how many cards are there total? 52 cards total. 52. Numerator is favorable, and favorable is a red card. So it becomes 26 by 52. If I ask you a question, what is the probability you select a king? So how many kings are there here total? 4. That is numerator, favorable events. Denominator total, and total are 52. So it becomes 4 by 52. What is the probability we select a card which is greater than 9 or 9 or more, which is greater than 9 or more, a number card? I cannot select KQK, they are not number cards. When I say 9 or more means what are the number cards we have? 9 or 10. And how many are there like that? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 cards are there, it becomes 8 by 52. Numerator is total favorable events, denominator is total possible events. This is when I select one card. Sometimes what happens, they'll ask 2 cards. And whenever it is selection is more than 1, we apply the concept of combinations. Now, if they ask you a question like this, you are selecting 2 cards. Out of 52, you are selecting 2 cards. So total possibilities 52C2. Denominator, we should select 52C2 because you are selecting 2 cards. And they'll ask you what is the probability both are red. So how many red are there? 26. So numerator will be 26C2 divided by 52C2. Calculations you forget, but numbers presentation you try to understand. 26C2 by 52C2. Okay. If they ask you the question like this, you select 4 cards. So what is the total possibility denominator? 52C4. Denominator, you are selecting 4 cards. Then the condition, what is the probability that 4 cards are spade? The number of spades are 13. You have to select 4 means 13C4. So numerator is 13C4 by denominator 52C4. Okay, let us say you select 3 cards out of total. So what is the total possibilities? 52C3. And they are asking what is the probability those 3 are face cards. So how many face cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. So numerator becomes 12C3. So numerator 12C3, denominator 52C3. So like that you divide the numerator and denominator. So if cards are there, it's a very good concept to understand the concept of probability. So many times people equate cards with gambling, but it is not. It is, you can use anything for gambling. Cards is mostly used, but it is a wonderful game of probability. If you purely see as a game, it's a nice game. Okay, so that's about probability. Then we have mathematical value of expectations. So basically it is an average. We use the word mathematical value of expectation, but in simple words, it is nothing but an average. So we have one column X, other column P. X is individual random variable and P stands for probability. So X is, let's say 100, probability is 0.8, X is 0, the probability is 0.2. So if I want an average, what will I do? I'll have to multiply these two columns. That's what if you remember, we do in combined mean or group mean. One column X, one column frequency, then we multiply and do the last column, do the total. That's what we do. One column will have for X, other column for P, then we multiply both. The total whatever we get is called as the X bar, or here they call it as E of X. Nothing but expected value, or they say mathematical value, but in other words, they are all means, it is nothing but an average. When I say mean, it is same as mathematical expectation, applying the concept probability, and total of probability, the property should remember, the total of probability should always be 1. Again, you can apply this concept in so many places. I'll give one simple example how you can apply in real life. Okay, I'll just give a numerical example. Again, don't write it, just for understanding. You don't have to write it. You travel by bus. If you don't take tickets, you save money. But if you get caught, you have to pay penalty. Now, just assume that you don't pay money. Will you get caught every day? Will not. So, you might get caught in some days. We don't know how many. Let's say that there are 30 days in a month. You get caught in 1 day. So what is going to be your loss or profit if I calculate? In 30 days, out of 30 days, 29 days you save money by not taking ticket. Don't do like that. Just giving example purpose. 1 day you get caught. So 29 days, let's say if you save 20 rupees per day, for simple calculation, in a month, ultimately you save 580 rupees. And 1 day you get caught and you pay penalty of 500. So you pay 500. Still, at the month end, you would have saved 80 rupees. If I do per day average, 80 by 30 days, and an average I'll save about 2.66 or 2.67 per day, my savings per day. If I convert this into this format, tabular format, how it looks like. One column for X, one column for probability. One column for X, I will save 20 rupees per day. The probability that happening is 29 out of 30 days. and I pay penalty means it is minus 500, and that probability is 1 out of 30. So multiply both x into p. So 20 into 29 by 30, 580 by 30. How much you get? 19.33. Then minus 500 into 1 by 30, I think you get 16.66 something. Minus 16.66. Okay. So find out the difference now. Do the total. You get 2.67, I think. Yeah, that's what we got average earlier. So this looks like mathematical formula, but ultimately what we're calculating is on an average. I just tell you, because I also told you I'll trade in stock market every day. Let's say I make around 100 trades. I do buy and sell, 100 trades I do. Many people think, no, 100 trades I have to be successful 100 times. I am not expecting to be successful 100 times. It's sufficient for me if I'm just successful 50% of the times. I'll show you how. Let's say 100% of the times, I'll play 100. 50 times I win and 50 times I lose. That is simple probability, 50-50. 50 times I win, 50 times I lose. But only rule I follow is one. When I win, I'll have to make at least 2 rupees. When I lose, I'll limit my loss to 1 rupee. So what do you think will be my total thing? In every trade, if I just make 1 rupee, 2 rupee, so I do trade 50 trades into 2 rupees, I make 100 rupees. Another 50 trades, I lose 1 rupee, I lose 50 rupees. At the end of the day, I would have made 50 rupees. If I just multiply this by 1 lakh. So each time I win, I'll make sure that at least I get 2 lakh, and when I lose, I'll limit my loss to 1 lakh. So 2 lakh into 50 minus 1 lakh into 50, at the end of the day, I still would have made much more money here. So the probability, and I don't want to have a 100% success rate. For me, success rate 50% sufficient. But I have to make sure that when I win, I get 2 rupees. When I lose, I would minus 1 rupee. That's what I was telling you for you also for examination. When your answer is correct, you get 1. When your answer is wrong, you lose minus 0.25. So when you lose also, you have to minimize that. So when you're not sure about the answer, do not make a guess unnecessarily. You lose on the negative marking system. Okay, that is what probability you can apply it in thousands of various ways. I'll just give one more quick example. I don't know whether you have checked in practical life. In casino, various games are there. One of the popular games is red and black. So they will have like red color something like this and black color button like this. And you throw a dice. You can bet on any of this. You can say the ball will be falling on the red, or you can say ball will be falling on the black. If it falls on the same side, you win. If it falls on the opposite color, you lose. So what is the probability? 26 here, 26 here. It appears it is 50-50. Because 26 red, 26 black. So what is favor? 26 by 52. But there is 2 more colors here and this, which is something which is not red and black. So if falls on those areas, you will not win. So it is not 26-26. It is 26 against 28. Your probability of winning is 26, but losing is 28. And with that small margin only, the casino people makes money. It is not visible to others, but a simple probability behind that calculation over there. So you know, right? It's always the case that in gambling people lose, but who will win always then? The casino people always win. So as a stock market investor, what will I do? I will buy the shares of casino company. In India, there is one company which is the owner of casino. That one company is in Goa. It's a listed company. So I will not go and play there, but I'll become owner of that company by buying their shares. Anyway, I'll not tell the company name. You try to figure it out. And one more small interesting fact over there. That casinos and all, if you go to Goa, you realize they'll always be on the ships. It will not be on buildings. If you ever wondered why, because in India, gambling is prohibited and that is law of the land. On water, you can do gambling. Anyway, how much true or not, you figure it out. You're also law students, but somebody told you, I told you as well. You figure it out. Anyway, but the probability is so much real if you truly apply it. Anyway, the formula is that average and variance formula, same as what we learned earlier. And some properties are also there, you can go through that. Anyway, so ultimately mathematical value of expectation, nothing but average. That's the only single point you should remember. One column is there for x, one column for probability. You multiply, do the total, what you get is x bar. Whatever is the property we learnt, what are the property we learned for measures of central tendency? That is, if all the observations are multiplied, mean also multiplies. If all the observations are subtracted, mean also subtracted, but standard deviation will not change. So those properties will apply even for mathematical value of expectations. Anyway, so go through the theory once, see if you have any doubts. Then we'll take up some problems. Yeah, regarding probability, one more example I give you popularly once, how you can use it in practical life. If you are driving two-wheeler, four-wheeler, or if you're driving, you're crossing the road. Just imagine you're driving two-wheeler. In Bangalore, you see people take so much of risk and they do overtake. The best part is everybody is in a hurry, but no people reaches on time. Everybody is in a hurry. So you take so much of risk, and ultimately what you end up is going to next signal and reach stop. That's what happens. But keeping it aside, what will you save by taking so much of risk and doing overtaking and all? You will save 2 minutes. Especially, BMTC road is coming, roads are so small. That too in Bangalore, Bangalore is always a work in progress. I think somebody would have, in olden days, they keep the gold and all in some places, right? Secret place. I think Bangalore, the gold must have been there in one of the underground here, I think. So every person will come and dig it. And that's a continuous process. So road is there only half, and there is left side is also some mud is there. Right side also space is not there, and bus is coming in between. And a person takes overtaking here, even if it is a two-way person to overtaking. Out of 100 times, 99 times, let's say you are so successful. So how much minutes you saved? 99 into 2 minutes. That's what you saved. But one time, opposite side also bus comes. So what you lose is life, or a lifetime thing which you cannot recover. So the risk is not worth it. So apply the concept of probability over there. Even if it is 99 times you win, one time you lose, that cannot substitute. So that's the concept of overall value. If I calculate, that becomes negative. So when you're taking risk in life, calculate if it happens, is it worth taking the risk? Probability is one of them. Anyway, so just go to the formulas and concepts once. From exam point of view also, this also is important chapter after the previous chapter. Comes for most number of marks. Okay, so no specific questions. I'll just discuss one small shortcuts. If it is coin problems, they'll ask you like, you toss a coin 3 times. How many possibilities are there? When you toss it once, there are 2 possibilities. Again you toss it, there are 2 possibilities. Again you toss it, there are 2 possibilities. Then you should not add, you should multiply. When one possibility can be done in m ways, another probability in n ways, then both of them is m into n. You're also going to learn in permutations, combinations. So number of ways whenever you get, you multiply. That's what we discussed also here, right? Independent events, intersection is number of ways multiplied by the other ways. You should multiply. So if you toss a coin, okay, let's keep it simple. If you toss a coin 2 times, so what are the possibilities? Head, head, both time head will come. Or heads, tail. First time head, second time tail. Or tail heads, or both time tail and tail. If I toss a coin 3 times, so you know total possibilities are 2 into 2 into 2, which is 8. But list down those 8. How do we list it? All the 3 may be heads, or heads, heads. Third time may be tail. Heads, tail, heads. Heads, tail, tail. Like that you should repeat totally 8. That you will miss out one. Normally if you do like this randomly, you will miss out one. So I'll give you one technique over there. So when you toss it 8 times, you do like this. Instead of writing it horizontally, you write vertically. It will be faster. So 8 times means you write 4 times heads and 4 times tail. Then you write half of that. That is 2 times heads, 2 times tail, 2 times heads, 2 times tail. Head, heads, head. 4 times head, 4 times tail over 2 times. Head, heads, tail, tail, head, heads, tail, tail. Then 1 time. Heads, tail, heads, tail, heads, tail, heads, tail. So like that you'll be able to fill it out. If it is not possible, but if you toss it 4 times, you know totally should be 16. So you write 8 head, 8 tails, 4 head, 4 tails. So that way you can reflect it. But popularly in exam, they'll ask you mostly 3 times only. So 4 heads, 4 tails, 2 heads, 2 tails, 2 heads, 2 tails, 1 head, 1 tail. So in the ratio, if you can write it, it'll be faster. Let's write once more quickly. So you toss it 3 times, 4 times you write head, and 4 times you write tail. 2 times heads and 2 times tail. 2 times heads, 2 times tail, and 1 time heads and tail, heads, tail, heads, tail, heads, tail. So 8 possibilities you have listed out in no time. So remember that. If it's a coin problem, toss 3 times. That will be helpful. And one more thing they can ask you is on 2 dice. Okay, if there are 2 dice, how many possibilities are there? Once you cross it, there are 6 times. If you again toss it, it will be 6 times. So total possibilities are 36. And listing it down 36 is one challenge. And second, what they ask you is, what is the probability that the sum is 10? So what are the possibility of 10? Or a sum is, let's say, 8. You can have 4 and 4 is 8. 6 and 2 is 8. 2, 6, 8. 5, 3, 3, 5. So many list is there. So for that, one small shortcut is there. See if you are able to follow it. When you toss a dice 2 times, it goes like this. The sum is minimum is 2 because 1, 1 is the minimum. You start from 2, 2, 3, 4, 5, 6, then 7 peak, 8, 9, 10, 11, 12. That's all the possibilities of sum. Because minimum is 1, 1, maximum is 6, 6. Minimum is 2, maximum is 12. But what are the probabilities of them? You start with 1, 2, 3, 4, 5, 6. 5, 4, 3, 2, 1. Write it logically, don't by heart it. You start from 2, 3, 4, 5, 6. You peak at 7, 8, 9, 10, 11, 12. Then probabilities are, you start with 1, 2, 3, 4, 5, 6. Peak at 6, 5, 4, 3, 2, 1. Okay, now here they'll ask you what's the probability the sum is how much you want. Okay, sum is 8. So 8 is here. The sum is 8, probability is 5 by 36. 36 is total, 6 into 6. So if they ask you what is the probability that sum is 11, 2 by 36. What is the probability that sum is 4? 3 by 36. What is the probability that sum is 6? 5 by 36. What is the probability sum is 6 or 7? That means I'll take this 5 also, this 6 also. So it will be 5 plus 6, 11 divided by 36. Any possibilities they can ask, you will be able to find out this. I'll rewrite it once more. Probability wise 1, 2, 3, 4, 5, 6. 5, 4, 3, 2, 1. 6 is the peak. Sum you start from 2, 3, 4, 5, 6, 7. 7 is the peak and you come down to 12. So anything, any of the sum they are asking, you will be able to fill out from this diagram. Again, don't by heart it, write it logically. Okay, let's do a problem based on this question only. A pair of dice is thrown. Find the probability that sum is 7. Let's rewrite this once more. This triangle. We start 1, 2, 3, 4, 5, 6 is at peak. 5, 4, 3, 2, 1. So probability wise, you start with 1, 2, 3, 4, 5. You peak at 6. 5, 4, 3, 2, 1. That is probability. Sum, you start from 2. Keep increasing. 3, 4, 5, 6. Peak at 7, 8, 9, 10, 11, 12. And probability sum is 7. So sum is 7 is at the peak. So it is 6 by 36. The sum is below, the probability is above. Okay, let's do one more of this kind. A pair of dice is thrown. The probability the sum is multiple of 4. Let's rewrite once more for practice. Let's start with probability 1, 2, 3, 4, 5, 6 at peak. So probability 1, 2, 3, 4, 5, 6 at peak. Then 5, 4, 3, 2, 1. Now sum is multiple. Sum also will write it. Sum will start from 2. 2, 3, 4, 5, 6. Peak at 7. 8, 9, 10, 11, 12. They're asking sum is multiple of 4. So what are the things multiple of 4 means I should select? 4 is 1. 8 and 12. 4, 8, 12 is multiple of 4. And you take the corresponding probabilities. For 4, probability is 3. For 4, probability is 3. For 8, the probability is 5. And for 12, probability is 1. So 3 plus 5 plus 1 divided by 36. Nine by 36. None of the above. When you toss a coin 2 times, or when you toss dice 2 times, or you throw 2 dice, both are same. Tossing it 2 times or throwing it both of them together, both are same. Then you can choose this method for sum of 2 dice. Okay, next. If probability of A slash B is equal to probability of A, then A and B are mutually exclusive, dependent, independent, composite. Okay, let's understand what is this probability of A means. P of A means probability of happening of event A. What is this A slash B? Probability of event A given or provided that B has already occurred and both are equal. So whether B occurred or not, probability of A remains same. Probability of A is probability of A. Even B occurred also, probability of A is same thing only. So whether B occurs or not, probability of A remains same. So A is not dependent on B. So A and B are independent. Whether B happens or not, probability of A is same. So that is independent events. If odds in favor is 5:7, odds against is 9:6, then the probability that problem can be solved is, okay, now first thing you should understand what is asked. Okay, there are two people, one is A and B. Now are they asking both of them should solve the problem or one of them solving the problem is fine? What is the probability that the problem can be solved? Have they asked both of them have to solve? One of them have to solve is sufficient. So what we have to calculate is probability of either of them solving, and probability of either of them I can write as 1 minus neither of them. So probability of either can be written as 1 minus probability of neither. Because they asked the problem can be solved either by A or by B. They just asked problem can be solved. So it is either. Is 1 minus neither. So what is 1 minus neither means? First person also fails, second person also fails. Neither means A fails and B fails. Neither of them means both of them are failing. A fails and B fails. Or symbol wise I can say A complement intersection B complement. A failing is A complement, B failing is B complement. Okay, now what is the probability of A falling here or failing here? Odds in favor is 5:7. So 5 is favor. We need failure. So this number is second, which is 7. And out of total 7/12. Because denominator we should take both 5 plus 7. And means we multiply. And B failing, and they said B against directly. So B against means I'll take the first number. So it is 9 by 9 plus 6, 15. You can make it into fraction, but it's better we make it into decimals. So 7/12 into 9/15. You get 0.35. And 1 minus 0.35 is 0.65. So which option gives me 0.65? I think 117/180 gives that number. .65. So options. Okay, next. Probability of A intersection B is 0, then the two events A and B are called as mutually exclusive. A intersection B means what is common to both. And what is common to both? Nothing. So if I write in diagram, how does it look like? I will write A like this and B like this. I will not mix both. And if they are separate, then that's what is called as mutually exclusive. If A happens, B does not happen. If B happens, A does not happen. They can be, but we don't know. They may be independent, may not be independent. The events connection, we are not sure. But we are sure that they are mutually exclusive because there is nothing common between them. When there is nothing common, they are separate. And the separate means mutually exclusive. And separate does not mean independent. Independent means they are not, they are not connected. Not connected is different from mutually exclusive. When anybody is in relationship, wherever that one person is there, you also be there. So that's called as intersection event. But after breakup, wherever that person goes, you don't go there, and you do the means other person will not come. So you become mutually exclusive events. So mutually exclusive means if one happens, the other will not happen. Okay, next. A letter is taken at random from the word range, and another is taken from the word page. The probability that they are of the same letter. Same letter means which letter? It can be A because A is found in both the places. Or it can be G also. G is in both the places. Or it can be E, which is in both the places. So it is A in both, or G in both, or E in both. Okay. Now if A has to select it from the word range, so how many letters are there? Totally there are 5, and you have to pick A means it becomes 1 by 5. The letter A is 1 and out of 5, so 1 by 5. And what about the letter A in page? There are 4 letters. So it is 1 by 4. And you have to select both the first one and the second one, so I multiply. Whenever it is and, we can multiply. I have to select in the first page, first word, and I have to select in the second word. First word is 1 by 5, second word is 1 by 4, and both of them is 1 by 5 into 1 by 4. 1 by 20. G in both, again G is only 1, so 1 by 5 and 1 by 4. So both of them means 1 by 20. E in both 1 by 5, 1 by 4 is 1 by 20. And what we do with these three? Either A or G or E. Whenever it is or, we will do plus. And means I will do multiply, or means I will do plus. That is one thumb rule you can remember. And is multiplied, or means plus. So 1 by 20 plus 1 by 20 plus 1 by 20. So total you get 3 by 20. So 3 by 20. What time you used to take lunch normally? What time? 1 o'clock. Just asked. Okay. Still the excitement is there. Good. We'll just solve 2 problems. After that, we'll go to third problem. Still not learnt. In accounts, you have one concept called as prudence principle. What is the prudence principle? All anticipated losses, you account for it. Gain, you wait. until it happens. Same way. Class also, until it is over, you should not think it is over. You should always think that class will be extended. Always think on prudence principle. Only when class gets over, the actual realization happens. Anticipated gain, don't account for it. Okay, having said that, let's go to next problem. If probability A is 5 by 9, odds against event A is. If you tell this problem correctly, we'll go to next problem. If you don't tell this problem, then I will explain, then we'll go to next problem. Still you have not learned the lesson. Your prudence principle need to be stronger. 5 by 9 means out of 9 times, 5 times we win and remaining we lose. So 5 times is favorable and 4 times is against, unfavorable. And they asked odds against. So first I should express the unfavorable. So it is 4:5 options. The 5 by 9 means out of 9 times, 5 times we win, 4 times we lose. And whenever we use the word odds against, that unfavorable should come first. So unfavorable is 4. If the question asked odds in favor, our answer would have been 5:4 only. Whatever favorable comes first. When odds against, unfavorable comes first. Okay, next. A player tosses 3 coins. If he wins, he wins ₹5. If 3 heads appear, ₹3. If 2 heads appear, 1. If 1 head appear, and loss of 15 if no head appears. Find his expected gain. I told you that this is what mostly happens, that is tossing a coin 3 times. So when you toss a coin 3 times, first you should know the probability of, in this case they are telling heads, 3 heads, then 2 heads, 1 head and no head. Okay, let's list down the possibilities. If you remember, I told you instead of writing it horizontally, let's write vertically. So 3 coins, 2 into 2 into 2, there has to be 8 possibilities. Let's write together 4 heads at once. So 1, 2, 3, 4. So 4 heads, then 4 tails, tail, 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 tail. Then 2 heads, 2 tails, heads, tails. So 2 heads, heads, tails, tails, heads, tail, tail. Then a single head, single tail. So heads, tail, heads, tail, heads, tail, heads, tail. Okay, so that's how 8 possibilities are there, and the question is based on number of heads. Or we'll just write it. I'll call it as X, number of heads. I'll say number of heads. Okay, what are the number of heads that you can get here? Either 3 heads, or 2 heads, or 1 head, or 0 heads. All or tail means 0 heads. And what we have to do is how much you get. If all the 3 are heads, what you get is ₹5. So I'll call it as X. X is random variable, ₹5. If 2 heads appear, you get ₹3. And if 1 head appear, you get ₹1. And if no head appear, you lose ₹15. Minus 15. You lose, so minus. And they're asking expected gain. So whenever it is expected value, I'll have to multiply it by probability. Now, out of 8 times, how many times exactly 3 head comes? Only once. So probability is 1 by 8. Only once all the 3 heads will come. And how many times? Exactly 2 heads. The first one you don't count it. Exactly 2 should be there. So the second one will come, head, tail, 2 heads are there. Head, tail, head, 2 heads are there. This will not come. Tail, head, head. This will come. This will not come. This will not come. This will not come. So totally 3 are there. So 3 by 8. And exactly 1 head. That is once, 2 times, 3 times. That is also 3 by 8. And no heads means all are tail. That also happens once. Then you multiply x into p. 5 into 1 by 8. Okay, 5 by 8. 3 into 3 by 8, 9 by 8. 1 into 3 by 8, 3 by 8. Minus 15 into 1 by 8, minus 15 by 8. And do the sum. So I think you get 2 by 8. And that is 0.25. And this sum is what is called as expected value, expected gain. That is option B. Okay, let's just solve 2 more problems. Let's see what happens after that. We'll just solve just 2 more problems so that halfway probability at least gets over. Let's do this. There are 2 boxes containing 5 white and 6 blue balls, 3 white and 7 blue balls respectively. One of the boxes is selected at random and a ball is drawn from it. And the probability that the ball is blue is. Sometimes when you see this kind of questions, now you feel like you have gone to some child's room where there are 2 boxes, white is there, blue is there, and you take one and put it another. People do think, why should I do all these things? Of course, one is we have to pass an examination. And one more thing, always remember, it is there for a purpose. People do ask this question. Who will use this a plus b whole square formula in life? Why it is required? All those kind of things. I do agree that they may not be applicable on a day-to-day basis. Some people will use it for sure. But more importantly, they are there to train your mind in the sense, if doctor tells you have less blood in your body, you need more blood. Will you go to blood bank and say that give me 1 liter blood I need to drink? No, when doctor says you need to have more blood, you means you eat something, you drink something, it will generate blood, not drink the blood straightforward. That's what the concepts in life also. When you have to solve a problem in life, you cannot learn only that. You have to train your brain accordingly. And for that only this mathematics, statistics problems are there. It is just to train your brain to think in a systematic way, nothing beyond it. So some people are argument saying, who will use this in real life? These are all waste. I will put the question other way around. You can't even solve a problem which is already taught, then how do you face problems in life which is not even taught? So first you learn the problem which is easy to solve. Then next step, you solve something unexpected. So according to me, examination is always easier than life, because in exam class, we teach you the lessons, then exams comes. But in life, always exams comes and then you learn a lesson out of it. So examination is still easier in that sense. Anyway, let's solve this one. There are two boxes. Okay, the question is one of the box is selected at random. Which box? It may be the first box or it may be the second box. Any of them can be selected. So first sentence will write like this. First box is selected or second box is selected. That is straightforward, simple. And then what we have to select? A ball is drawn from it and the probability that we are selecting a blue one. So what are the possibilities are there? First box is selected and then you draw blue one out of it, or you select a second one and you draw blue one out of it. So you write down the sentence first. First box is selected and then you draw the blue one. That is one possibility. Or you select the second box and then you draw a blue one out of it. And remember the rule, whenever it is and, we multiply, or means we do plus. So first box selected and the drawn is blue, or second is selected and then the drawn one is blue one. Okay, now what is the probability of selecting the first box? There are two boxes. So what's the probability of selecting the first box is 1 by 2. And means multiply. And from the first box, you have to select the blue one. And look at the first box, see how many blue ones are there. There are 6 and out of total 11. So probability is 6 by 11. Total is 11, favorable is blue ones, 6 by 11. Or means plus. What is the probability of selecting the second box? Again 1 by 2, only 2 boxes are there. And means multiply. Drawn one is blue one. And in the second box, 3 white is there, 7 blue is there. So totally 10. And favorable is blue ones, 7. So 6 by 22 plus 7 by 20. You can simplify, but we'll go with decimals. 6 by 22 means 0.27. 7 by 20 means 0.35. So 0.62 should come. So 115 by 227 will not come. 83 by 250 also will not come. 137 by 220. Yeah, I think that is 0.62. So 137 by 220. Okay, so hope you got it one. Let's go to the next one. A random variable x has the following probability distribution. X is given. P, the probability is given. Find E of x square and the E of 2x plus 5. In fact, there was two things. One of them you calculate also, you will get it. But anyway, let's do both for practice purpose. X, let's write it down. Minus 2, 3, 1. Then probability. 1 by 3, 1 by 2, 1 by 6. Then we know we'll multiply x into p. So minus 2 into 1 by 3, minus 2 by 3, 3 into 1 by 2, you can take decimals also, 3 by 2. I think you can take decimals. Minus 2 into 1 by 3, minus 0.666, minus 0.67, 3 into 1 by 2, 1.5, 1 into 1 by 6, 0.1666, I'll make it as 0.17. I think 1 you get. Okay, 1 is called as E of x. Expected value of x, nothing but average. But they have not asked that. What they have asked is E of x square. So what did I do for x? I did x into p. And for x square, I need one column for x square. X is minus 2, square it. 2 square 4, 3, 3 square 9, 1, 1 square 1. And then what I should do is x square into p. So 4 into 1 by 3, 1.33, 9 into 1 by 2, 4.5, 1 into 1 by 6, 0.17, 6.5 something. Sorry, x square. You get 6 or 7? 6 you get, okay. Okay, this is E of x square. You can select option A because you got the E of x square already, because the 6 is there only here. Just for confirmation, we'll do another, because in some problem they might tell 6 and 7 and 6 and 5, only in that situation. We need 2x plus 5. So what I can write is this, E of 2x plus 5. You treat this like an equation. I don't know whether you remember, long time back we did. That is in the last chapter. Because you know, you believe in first in, first out. No, in accounts and all you learn first in, first out. Learn first, forget first. So 2x plus 5 means each observation is added by 5 and each observation is multiplied by 2, change of scale, change of origin. And with respect to mean, I don't do any change. We simply substitute. But if it is a standard deviation, the plus 5 is ignored, constant. So here, no ignorance, everything is considered. So I can write it as 2 into E of x, simply substitution, plus 5. E of x we calculated as 1. So 2 into 1 plus 5, that is 7. So E of x square is 7. E of 2x plus 5, E of x square is 6. 2x plus 5 is 7. So it is 6 and 7, option A. Okay, so half probability chapter we did, remaining half we'll take it. Okay. Okay, no, I like that silence, no? When I say silence, people don't stop, but when I say that after that means people will be silent. Anyway, we'll take a break now, 1:15. Let's have break till 1 hour, 2:15. 1 hour. For lunch, you need to have it because only then you'll get re-energized. I don't want you to come to the class tired. So take your time, eat slowly, don't eat in a hurry, take break, go outside, have a walk, and come back. 2:15 we'll meet, 1 hour. Moving on. Next question in probability. Amitabh plays a game of tossing a dice. If the number is less than 13, he is getting A. Otherwise, he has to pay 10. If the game is fair, find A. When they tell game is fair, That means nobody is at advantage position, everybody is equal. And another words, when they say game is fair, you can take it as E of x is 0. Nobody is at advantage. Expected value is 0. Okay. If the number is less than 3, he is getting A. So x values is either he gets A or otherwise he has to pay 10. Pay 10 means x value will be minus 10. And what is the probability which we have to ascertain? Number is less than 3. Less than 3 means either it will be 1 or 2. So probability is 2 by 6. And remaining it is 4 by 6. And you multiply. That's what you get E of x. And that E of x is given as 0 because game is fair. How that is 4 by 6? Because when you play a dice, only 6 possibilities are there. 2 possibilities are less than 3, 1 and 2, and remaining are 4. Or even if you count, it is 3, 4, 5, 6. 4 possibilities. So multiply and solve the equation. A into 2 by 6, you get 2a by 6. And minus 10 into 4 by 6, minus 40 by 6. Solve the equation. 2a by 6 minus 40 by 6 equals 0. So you can say 2a minus 40 by 6, that is same denominator, is 0. Cross multiply. 2a minus 40 is 0. 40 goes to right side, that becomes plus. So 2a equals 40. So 40 by 2, a becomes 20. When the game is fair, you take it as E of x as 0. Okay, that is question number 11. Okay, next. The probability distribution of a random variable is as follows. The variance of x is. Okay, so variance formula, in this case sigma, and here we have probability also, so we can't use a simple formula, we'll use this E of x square minus E of x the whole square. So when probability is there, we'll use this formula for variance. How to calculate E of x and E of x square? We have done it earlier. So let's do this in 2 columns. But important thing is they have not given probability correctly. They are just told k, 2k, 3k, 3k and k. So we'll use one of the properties, that is sum of probability should always be equal to 1. Total of probability is always 1. And here if you add all, k plus 2, k plus 3, k plus 3, k plus k. So 3, 3, 6, 2, 8, 9 and 10. So you get 10k equals to 1. So k equals 1 by 10, or we can say 0.1. So now you got the values of k, substitute and prepare the table. X values they have given 1, 2, 4, 6, 8. Probability, now don't write it as k, in place of k you put 0.1, and in place of 2k if I do 0.1, 2 into 0.1 is 0.2. Similarly, then 0.3, again 0.3, and then you get 0.1. We need E of x, so multiply the two columns, x into p, that is 1 into 0.1, 0.1, 2 into 0.2 is 0.4, 0.3 into 4 is 1.2, and 0.3 into 6 is 1.8, 0.1 into 8 is 0.8. So do the total, what you get is E of x. That is 4.3. Then I need x square because I need E of x square. So have one x square column. 1 square is 1, 2 square 4, 4 square 16, 6 square 36, 8 square 64. Then you need x square into p. That is the probability column multiplied with x square column. So 0.1 into 1, that is 0.1. 0.2 into 4 is 0.8. 0.3 into 16 is 4.8. 36 into 0.3 I think is 10.8. And 64 into 0.1 is 6.4. And do the total. I think you get 22.9. And this we call it as E of x square. And variance, I have just given the formula above. That is E of x square minus E of x the whole square. E of x square is 22.9 minus E of x the whole square, that is 4.3 square. 22.9 minus 4.3 square is 18.49. So variance is 4.41. So variance is that E of x square minus E of x the whole square. Okay, so next this option is B. E of 13x plus 9. Again the property, if you remember, that is mean is dependent on both. So 13x plus 9, so in place of x you can write it as E of x, and plus 9 continues as it is. So 13 into E of x plus 9, that is option C. We have kept it as it is. If it was variance or standard deviation, this plus 9 we would have ignored it. So answer is option C. If two random variables are given, standard deviation is 2. What is standard deviation of y? Again, they have given random variables, but the property is change of origin, change of scale. So we have given y equals minus 2x plus 3x plus 4. And they are given standard deviation of x is 2. We need standard deviation of y. So the property what we should do is this plus 4 constant is ignored, independent of origin. So minus 3 into, in place of x, I can substitute as 2. I get it as minus 6. But standard deviation again cannot be minus 6. So we'll write it as plus 6. So answer is option B. Range cannot be negative, mean deviation is not negative, quartile deviation not negative, standard deviation cannot be negative. So in those cases, even if it is negative, you write it as plus. Okay, next one. The probability of sample space is, the answer is 1. Sample space means all possible events. All possible events put together is called a sample space, and one of the events will happen. Therefore, it is 1. Sum of probability is 1. In class, 40% students read mathematics, 25% biology, 15% both maths and biology. One student is selected random. The probability that he reads mathematics, if it is known that he reads biology, is, let's give the notations there. 40% read mathematics, so let's write it as probability of M is 40%. 25% biology, so probability of B is 25. 15% both, and both we write it as probability of M intersection B. Both means intersection or means union. So both mathematics and biology common to both, so intersection, and that is given as 15%. And what is required? He reads mathematics, known that he reads biology. So how do we write it? Probability of reading mathematics given, known, means slash. He reads biology, so we write it as M slash B. Probability of mathematics known means slash, that is given, that B. And whatever event happened, that will be in the denominator. So probability of B will be denominator and numerator will be the intersection. Probability of M intersection B. Intersection we know it is 15 and probability of B is 25. So 15 by 25. Which is same as 3 by 5. So option B. Conditional probability, whichever event occurred will come in the denominator. Numerator is the intersection. In this problem, it is known that he reads biology. So whatever is known is in denominator. If the question said if he reads, known that he reads mathematics, then instead of 25, I would have taken it as 40. Okay, next. There are 3 white and 2 black balls in urn 1. Urn means you can take it as box. 4 white and 6 black balls in urn 2. If one ball is taken at random from urn 1 and transferred to 2, and the ball is taken from urn 2, the probability that the ball drawn from the urn 2 is white is. Okay, so there are 2 things happening. One, you are transferring from urn 1 to urn 2. So one ball is taken from urn 1 and transferred. That is one transaction happening. And another one, after that, you are selecting from urn 2. So now transferred one should be which one? Have they told transferred is black or white? They just told it is transferred. So transferred one can be black also, or it can be white. That is first point. Second, when you draw from the second urn, and that has to be white. So what are the possibilities if you list it out? First one, you transfer white or you transfer black. And the second one, you have to draw white one only. After transferring, what you have to draw is white. So you write that in sentences. Transferred is white, and then drawn is white, or transferred is black, and then drawn should be still white, because condition is last drawn should be from white. So write that sentence, then we'll apply the probability numbers. Transferred is white or transferred is black, and then drawn is white. Okay, now transferred is white. What is the probability of transferring white? Look at the earned one. There are 3 white and 2 black. So white you have to transfer means this has to be 3 by 5. You don't have to go for combination because you're selecting only one. If I select 2, then I'll do 3C2 like that. Only one, you can keep it simple, 3 by 5. And or transferred is black. So here I'll write it as 2 by 5. 3 white, so 3 by 5, or black, 2 by 5. And we have end means we are going to multiply. And this one, tell me carefully, you're drawing whites. How many whites you are going to select from the second urn? Second urn has 4 white and 6 black balls. But before that, what is the another event that is taking place? You are transferring white. So actually it is not 4 white. It will be 5 white because you are taking transfer of 1. So 5 white out of total 11. It becomes 5 by 11. And why 5? Because 4 was there, 1 got added. And why 11? Because 10 was there, 1 got added. So it is 5 by 11. Second one is trickier one. Be careful. How much white is there now? In the second urn, it is only 4 because the transferred one is black. So white is still 4 by, but total becomes 10 was there, 1 transferred. So that becomes 11. And or means we are going to do plus. So simplify. This is 15 by 55. This is 8 by 55. And 55 you take it common. 15 plus 8. So 23 by 50. So whenever these box problems and all is there, the writing this sentence is the key. What is transferred and then what is drawn. And whenever and, I'll multiply, or means we will do plus. Okay, next one. The bag contains 15 1 rupee coins and 25 2 rupee coins and 10 5 rupee coins. I don't know what you get to know, but whenever we see this question, I think it must belong to a beggar bag, I think. Now, who will have 15 1 rupee coin, 25 2 rupee coin? Anyway, if you select a coin from his bag, a coin is selected at random from the bag. What is the probability of not selecting 1 rupee coin? Not selecting means it will be either 25 rupee, 2 rupee coin or 5 rupee coin. So 25 or 10. We will do 25 plus 10. Whenever it is or, we'll always multiply. So it is not 1 rupee, means it can be 2 rupee or it can be 5 rupees. So 25 or 10, so 25 plus 10, and out of total 50, I think. 25 plus 15 plus 10. So 35 by 50, that is 0.7. Yeah, you can do. Probability of selecting a rupee is 15 by 50, you get 0.3, then 1 minus 0.3 is 0.7. That's also fine. Okay, next. Probability of A is 0.45, probability of B is 0.35, probability of A and B. A and B means probability of A intersection, and means intersection, or means union. A intersection B is 0.25 and A slash B is. So what is the formula for probability of A slash B? Denominator is whatever event occurred, and which event occurred is B. What comes next is the event occurred. So denominator is probability of B, and numerator is the intersection. Probability of A intersection B. So A intersection B is 0.25 and probability of B is 0.35. So 0.25 by 0.35. I think 0.714. 0.714. So whatever event happened, that will be in the denominator. Don't read as divided by, you read it as given, or event that has already occurred. Okay, next. The probability that a cricket team winning a match at Kanpur is 2 by 5 and losing a match at Delhi is 1 by 7. What's the probability a team winning at least one match? So when I say at least one match, should we calculate union or intersection? At least means union. If they ask you both the match, that becomes intersection. So we need to calculate probability of at least one, union, and probability of at least one, we can write it as 1 minus probability of none of them. That is what we have written earlier also. Probability of either can be written as 1 minus probability of neither. You lose both the matches. So at least one match, 1 minus losing both the match. So 1 minus none of them means you lose the first one and second one. So first one is lost and second is also lost. Or in symbol wise, we say A complement intersection B complement. Both are lost. First is lost and second also is lost. First is lost. What is the probability? Probability of winning is 2 by 5. So losing becomes remaining 3 situations. So it is 3 by 5. And second they have given directly losing only. So I can take it as it is 1 by 7. So 1 minus 3 into 1, 3, 7 into 5, 35, cross multiply, 35 minus 3 by 35, so 32 by 35. Okay, so that is the last problem in probability. Okay, so this is about probability chapter, definitely one of the important chapter. Now let's go to the next one, which is theoretical distributions, which is extension of probability chapter again. So It is very difficult to differentiate sometimes between probability chapter and theoretical distribution chapter. So theoretical distributions are same as probability because this will follow a particular pattern. For example, when you toss a coin, there are two possibilities. If you toss the coin 2 times, then 2 into 2, there are 4 possibilities. If you toss a coin once more, then 2 into 2 into 2, there are 8 possibilities. And if you toss a coin 10 times, then 2 into 2 into 2, then we have to calculate so many times, that becomes too big calculations. So we have this chapter, theoretical distributions. So when a probability follows certain particular pattern, here we apply theoretical distributions. Many patterns are there. We are not going to read everything. As far as syllabus is concerned, there are particularly 3 patterns. One is binomial distribution, Poisson distribution, normal distribution. Only 3 patterns, 3 distributions, but ultimately remember, these 3 will compute probability only. That basic you should not forget. So by applying binomial distribution, we calculate probability. By applying Poisson distribution, we calculate probability. By applying normal distribution also, we calculate probability. But the rule is, these things will follow particular pattern. And what pattern? Binomial distribution follow a pattern of this. That is, like a tossing a coin, it will have a particular n, tossing a coin 5 times, 10 times, like that. And more importantly, each trial has 2 possible outcomes. If there are 3 possible, I cannot use binomial. So 2 possibility means head, tail, true, false, or winning, losing, yes, no. Only 2 possibilities are there. We apply binomial distribution. Other situation I cannot apply. Then what is Poisson? I mean, we'll come to formula. Poisson distribution means where n is large, p is tending to 0, or we say on an average in an interval. Let me give an example. We say between 9 o'clock to 10 o'clock in a traffic signal, there will be 500 vehicles. So we are expressing on an average and between an interval. The probability is very small. Number of vehicles is, I mean, in that time, number of vehicles is small, but average would be, we are expressing. One more method we can say, on any given day in a hospital, there will always be a demand for 2 beds. So within an interval, we are calculating an average. Between 9 o'clock to 10 o'clock, a board will receive at least, or an average receive 7 phone calls. So we, between a certain interval, we express average. That becomes Poisson. Formula will come to it later. And normal distribution is actually applied in general. In fact, binomial distribution and Poisson distributions are called as discrete distributions. Discrete means the value of x cannot be negative and cannot have decimals. You see 0, 1, 2, dot, dot, till n. But normal distribution, there are no restrictions. It can be any number. Let's look at the properties of binomial distribution. The formula is given by this probability, and here also Poisson also gives you probability. Normal distribution also gives you probability. Ultimately, we calculate only probability. And in the probability function, we have NCX. C is the combination. N is number of trials. That is n. So if you toss a coin 10 times, the question will be how many times you draw? Exactly 3 heads. So number of times is 10, that becomes n. And how many times you choose 3 heads, and that becomes x, the random variable x. So n is number of trials, x is a specific number, p is probability of success, q is probability of failure. Only 2 things can come, p and q, and power is n minus x. And some properties you should remember in case of binomial distribution. You can say formula. Mean of a binomial distribution is n into p. N is number of trials, p is probability of success, variance is npq, and distribution is symmetrical. Symmetrical means if you plot it on a graph, the left side and right side looks exactly like a mirror image. That's called a symmetrical, and that will happen when probability is 0.5. Poisson distribution, probability formula is this: e power minus mu, mu power x by x factorial. E stands for Euler's constant. It's a constant number, approximately 2.7183, but you don't have to remember that number. They will give you what is that e power minus 1, minus 2, how much? They'll give in the problem itself. Question only they'll give you. And mu here means average. Poisson distribution ultimately requires average. Some people use this symbol mu, some people use this symbol lambda something. Don't worry about the symbols. Ultimately, this is the average we are going to take. Mu here means average. I mean, this is all the formulas given by foreigners. So we are using the symbol alpha, beta, mu, lambda and all. If it was introduced by Indians, we would have had some Om, swastik and all. So don't worry about the symbols there. It just means notation, nothing beyond it. That does not carry any value. Normal distribution looks like this. So it's called as normal curve. It's bell shaped. So on x-axis we'll have x values and y-axis we'll have the probability, and total area, that means total probability, is always 1. And it's at bell shaped. You can see it is at bell shaped and has one peak, and at the peak points you see mean, median and modes. So we'll say that, you know, the middlemost value is mean, and the left extreme is minus infinity, right extreme is plus infinity. In between on an average. Now this, we have one big formula also. Instead of applying this formula to calculate the probability, there is one table available that's called as normal distribution table or biometrica table. This has x values, and we will convert the x values into z. Only then I can make use of the table. And you don't have to carry the table. Whatever the value required, they'll mention in the problem itself. But you should know the interpretation part of it, which let me tell you. So how do we convert from x to z? They'll give you the, I mean, this is a formula to remember. Z equals x minus mu divided by sigma. X values, they will give you x values. Mu means mean, and the standard deviation sigma is the standard deviation. So this will give you the z value, and you plot the z value in the graph and you try to estimate the probability. For example, I mean, this is normal distribution, and when I convert it to standard normal distribution, the normal curve, something like this, actually it becomes 0. This is minus infinity and plus infinity. They'll give you something like this symbol, 5, 2 is something like 0.97, let's say. And that symbol means, this is pronounced as 5, phi, 5, 2. But what you should know is the interpretation. This means, phi 2 means starting from minus infinity till 2, that is if 2 is here, starting from minus infinity till 2, this region, this entire region is 0.97. The area under the normal curve is probability. And you know total area is 1. So total curve also will give you 1. And up to this 2, the answer is 0.97. And if you want remaining, what would you think would be the remaining portion? Let's say, let me highlight in yellow. The total area is 1. And this region, let me say, I'll highlight in blue. This blue region represents 0.97, starting from minus infinity till 2. So blue region is 0.97. The total area is 1. So yellow region represents the complement, 1 minus 0.97, that is 0.03. Like that we are going to calculate the probability values. So curve is symmetrical in nature. So left side and right side is exactly mirror image of each other. But actually if you apply, normal curve is also inherently applicable in human life also. So if I can apply, if you represent the happiness in the graph, you will be happy too high only few times. You will be unhappy only few times. But most of the times you will be like does not matter in life. Every day you will not be happy. Every day you will not be unhappy. Only few days you will be sad. Only few days you will be happy. That is, chances are very, very less. And most of the times your life goes on an equal manner. Class also you can take. Some people get very high marks, some people get very less marks, and most of the people will be around average. You can take traffic signal also for that matter. When you start the day or end the day, traffic will be less. During the day, the traffic will be at peak. So anything you apply, you will always be able to divide this into a normal graph. It may be to the traffic, it may be to the marks of students, salary of people. Some will get too high salary, some will get too less salary, and most of them will get an average salary. So everywhere this concept can be applied. Now, when I say symmetrical in nature is in your body only. You look at your hands, they are mirror image of each other. That is what is symmetrical is all about. I mean, any parts, what you think, you can apply it in normal curve. Anyway, the left side of the area is 50%, right side of the area is 50%. And these two formulas also you should remember. In standard deviation, I mean normal curve, quartile deviation is 0.67 standard deviation and mean deviation is 0.8 standard deviation. An important property is mean, median and mode all will be at a single peak. That's at the middlemost point in normal curve. Okay, so this is what is mainly from exam point of view. Each of the property what we have seen now can be a problem in exam. Oh, one more thing I should discuss. That's called as 68, 95, 99 rule. Not 30, 60, 90 rule. That comes in different place. When I say 68, 95, 99 rule, it means if I plot a graph, I assume it's a normal curve. It may not look like. We start with in between, which is mu. If I go one standard deviation left side, one standard deviation right side. One standard deviation left side, I call it as mu minus standard deviation. And I go right side will be called as mu plus standard deviation. This area is 68%. So if I move one side, one standard deviation, that area covered is 68%. If I move further, two standard deviation, then that covers 95%. And if I go three standard deviation both sides, and that is covering 99.73%. So how much area covered under one standard deviation, two standard deviation, three standard deviation under the curve? That is what is 68, 95 and 99 rule. So go through the theories once more for 2-3 minutes, then we'll take up the problems. Okay, so any doubts in any of these formulas or properties? Each of the property can be a direct question in the exam without any calculation. So popular question is like total area under normal curve is 1, area from minus infinity to mu or mu to infinity 0.5, 0.5. So each of those property there can be a direct question in examination. Okay, let's take up the problems. Mean of a binomial distribution is 6, variance is 2, find P. Mean formula given by NP in binomial distribution and variance is NPQ. So mean is 6, NPQ is, that is variance is 2. So you can substitute NP here. So NP is 6, Q is, Q as it is. Q equals therefore 2 by 6, or you can simplify it as 1 by 3. And I need P, and P is 1 minus Q. That is the probability of success is 1 minus failure. So 1 minus 1 by 3, that is 2 by 3. Okay, next. In the normal distribution, mu minus 3 sigma, mu plus 3 sigma is equal to, this is what I told you based on 68, 95, 99.73 rule. And this is covering 3 standard deviation left side, 3 standard deviation right side. So 68 is 1 standard deviation, 95 is 2 standard deviation, and this is 99.73. So option A. So you can see there's nothing to calculate. You just need to remember those properties. 68, 95, 99.73 rule. Wages paid to workers follow normal distribution, because wages paid can be any number, can be decimals, it is continuous, and continuous means we have only one, that is normal distribution. In binomial distribution, if mean is k times the variance, then the value of k will be mean is k times means multiplied by k, variance is variance. So mean is k into variance. And the property of binomial distribution, mean is NP and variance is NPQ. Okay, let's simplify. K into NPQ. So NP and NP can be cancelled. N is also here, P is also here. So what remains is 1 here, and this is K into Q, or K I can write it as 1 by Q. And what is Q? Q is nothing but 1 minus P. So 1 by 1 minus P. Option D. 1 by 1 minus P. Each of these property, as I told you, can be a question in examination. So statistics, actually we have less shortcuts, we have more shortcuts in mathematics. Statistics are conceptual, so you should remember these properties. But it is faster, calculations are less. But shortcuts are available most in mathematics. Okay, let's go further. Standard deviation of a binomial distribution is variance, we have seen NPQ. So standard deviation is square root. So square root of NPQ. And all these questions, whatever we are solving, are all exam questions only. Each and every question what you are solving is examination question. So these are all what has come in the past and can come in the future. In binomial distribution, the parameters n and p, then x assumes the value between 0 and n, 0 and n both inclusive, 0 and 1 between 0 and infinity. It's 0 and n both inclusive. Both inclusive because if I say coin is tossed 10 times, n is 10, and in all cases I can get head. So they can ask you in how many cases you get 10 heads. So in that case the number of times is also 10, x is also 10. So n is included in the x value. So 0 to n both inclusive. It can be 0, it can be n. In dash distribution, mean equal to variance, that happens in only Poisson distribution. Mean and variance both are equal. Again, the property of Poisson distribution. Under normal curve, mu plus or minus 3s covers. Again, 3s covers means 3 standard deviation left side, 3 standard deviation right side. That is again 99.73%. See, even 99 is not sufficient. They'll give you 73 also, 37 also. So you have to remember very clearly, that is 99.73%. It is 68, 95, 99.73. If it is one standard deviation, it is 68%. If it is 2s, 95%. 3s, 99.73. Always you should write the full answers. And you should remember also full answers. I don't know whether you heard of it. We have a statement like this. Normal questions, 1 over how many balls in cricket? 1 over how many balls? 6. That is what you get the answer. Normal in BCom exam, you get foot marks. In CA exams, you don't get full marks. Then what is the right answer? It is 1 ball delivered 6 times. You have to be clear, accurate. So just 99 not sufficient, 99.73. But even that will not give you full marks. Then how the full marks, full answer has to be 1 ball delivered 6 times. In matches where a team batting first gets all out within 50 overs or 20 overs, in the last over there will be less than 6 balls being delivered. A team batting second gets all out within the scheduled time, or they reach the target, then in that last over there will be less than 6 ball being delivered. In a situation where there is no ball and wide, there will be more than 6 balls being delivered. In a situation where ball is hit out of the ground and could not be taken back, and the umpire decides that the ball has to be substituted by new ball, in that case in 1 over there will be 2 balls being used. Only when you write full, you get the full marks, and that is what is CA exam is different from other exams. Anyway, let's go further. If 6 coins are tossed simultaneously, then the probability of obtaining exactly 2 heads is. So here we apply binomial distribution, because either you get only head or tail, only 2 possibilities. And the formula let's write down. In binomial distribution, probability is given by NCX P to the power of x and Q to the power of n minus x. And n here tossed 6 coins, so n equal to 6. Probability not given, and probability not given we will take it as half, or you can say 0.5. In general, that is what we say, probability is half. And Q is also same thing, probability of failure is also half, 0.5. And what is x? They are asking exactly 2 heads. So x is equal to 2. So probability we need to calculate NCX, which is 6C2. Probability 0.5 to the power of x is 2. And Q is also 0.5 to the power of n minus 6, that is 6 minus 2. So little bit of combinations required. 6C2, we will write it as 6 into 5 divided by 2 into 1. Why only 6 into 5? Because 6C2, only 2 factors. If it was 6C3, then I'll say 6 into 5 into 4, 3 terms. And divided by factorial. This is 2 is there. You start from 2, you keep multiplying till you go to 1. Just for discussion purpose, what will you write it as 10C4 if it was there? We start with 10, 9, 8, 7, 4 factors, 10, 9, 8, 7, 4 factors, then divide by, start from 4, 4, 3, 2, 1. That's the expansion of combinations required at this point in time. More application we'll do in that chapter later. 0.5 square is 0.25, and this is 0.5 to the power of 4. Zero point 0625. So into 0.25 into 6 into 5 divided by 2, 0.23. So you get 0.23. So 0.23, let's go with options where I get 0.23. I think option C gives me that number, 15 by 64 is 0.23. Okay, next. If 5% of the families in Kolkata do not use gas as fuel, what will be the probability of selecting 10 families in random sample of 100 who do not use gas as fuel? So actually, if you look at this problem looks like a binomial distribution problem because either they use or they don't use. Only two possibilities. But look at the n number of observations, random sample of 100. So n is hundreds. And probability is 5%, which is 0.05. So when n is large, p is small, binomial distribution will actually become a tends to Poisson distribution. Because if it is n is 100, I cannot do 100 C5 and all. It's a too big number to solve. Or one more hint in the exam, when they give you like this e power, it is going to be Poisson distribution problem. So that hint also you can make use of and decide that this problem is based on Poisson distribution. And Poisson distribution, probability of x is e power minus mu, mu power x by x factorial. What is mu in this case? Mean, that is, you know, n into p. Number of families hundreds, probability 5%. So mu is 5. And what's the probability that how many people? Probability of selecting 10 families. 10 families means x equals to 10. So we need to calculate probability of x equal to 10. So substitutes e power minus mu, mu is 5, mu power x, 5 to the power of x is 10 by 10 factorial. E power minus 5, that is given already, 0.0067. 5 to the power of 10, how do you calculate 5 power 10 in the calculator? You start with 5 into, you keep pressing equals to 9 times only. You press one less number of times. So it is 10, so you press equal to 9 times. You will get a big number, but that's okay. So 5 into equals 9 times. I think you get 97 lakh. 65,625. And 10 factorial means 10 into 9 into 8 into 7. Keep multiply till 1. That's also big number. So I think you get 36 lakh 28,800. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. You get, I think, 0.018. So option D, 0.018. Okay, next. If x is a Poisson variate, that probability of x equal to 0 is equal to 1, then probability of x equal to 2 is. Okay, they have given an equation, let's write it. Probability of x equal to 0. And what is the formula of Poisson distribution? E power minus mu, which I don't know. Then mu to the power of x. X here they said 0. So mu to the power of 0 by x factorial, that is 0 factorial, is equal to x equal to 1. So e power minus mu as it is, and mu to the power of x, x is equal to 1 by x factorial is 1 factorial. So e power minus mu can be cancelled. 0 factorial, 1 factorial equals, that is anyway 1. This e power minus mu is cancelled. Mu to the power of 0 is 1. And mu power 1 is mu itself. So what we get is mu is equal to 1. Then you substitute the second one asking probability of x equal to 2. So e power minus mu, mu to the power of x is 2. I mean, they're asking probability of x equal to 2. E power minus mu, mu is in this case 1. Mu to the power of x, 1 to the power of 2 by 2 factorial. And in mathematics, you know, e power minus 1, I can write it as 1 by e. When I take denominator, the minus 1 becomes plus 1. So I'll just write it as e. And 2 factorial means 2. So 1 by 2e. Option C. Okay, next one. If the mean of a Poisson variable is x, then what is probability of x? At least 1. Mean means mu, mu is equal to 1. And probability of at least 1 means probability of x greater than or equal to 1. And greater than equal to 1 I cannot calculate directly, so what I'll do is I'll write it as 1 minus probability of x opposite of greater than, that is less than 1. And what is the only number less than 1 possible is x equal to 0. Because in Poisson variate, random variable cannot have negative numbers. So only number less than 1 is 0. Substitute in the formula. It is 1 minus e to the power of minus mu, that is 1. Mu to the power of x, 1 to the power of 0 by x factorial, that is 0 factorial. So 1 minus e power minus 1, we can write as 1 by e. I told you when you take it to denominator, that will become plus. 1 to the power of 0 is 1. 0 factor is also 1, so you can ignore it. So what we have is 1 by 1 minus e. So they have not given that value, but approximately we know e value is 2.7138. That's one approximate value I have given earlier. 2.7138 or 83, sorry, 2.7183. Simplify 1 by 2.738 and subtract 1. .63. So 0.63 is option C. Okay, next. For a normal distribution with mean 150, standard deviation is 45, find Q1 and Q3. For a normal distribution, Q1 formula is given by mean minus 0.6745 standard deviation. So mean is 150 minus 0.6745, standard deviation is 45. Make sure you calculate that within brackets. So that will give you 119.65. And Q3 will be, instead of minus, you do plus. That is 150 plus 0.6745 into 45. That is 180.35. So 116, 119 and 180, that is option B. Okay, next. In a sample of 800 students, the mean weight and standard deviation of weight found to be 50 kg and 20 kg respectively. On the assumption of normality, what is the number of students weighing between 46 and 62 kg, given the area between Z20 to Z2 is 0.0793 and area between Z20 to Z2 0.6 is 0.2257. Okay. They said mean is 50 kgs, that is mu, and standard deviation is 20. So standard deviation is 20. And what they're asking is students between 46 and 62. So probability of 46 less than x less than 62. That's how we calculate between. Lower limit is 46, upper is 62. In between that we are calculating. But with x values, I cannot simplify. We should convert x values into z values, and z value is obtained by x minus mean divided by standard deviation. And therefore z equals x is 46 minus mean is 50 divided by standard deviation, that is 20, less than x minus mean, which is 50, divided by standard deviation 20, less than 62 minus 50 divided by standard deviation 20. That is a probability we have to calculate. From x values, we are converting it to z values by subtracting mean and dividing by standard deviation. So this is 46 minus 50 is minus 4, minus 4 by 20 is minus 0.2, is it? 25. Minus 0.2, less than, this is z, and less than 62 minus 50, 12, 12 by 20 is 0.6. So if you plot in the graph, so what I need, you write the middlemost value as middlemost value as 0, left extreme as minus infinity, and right extreme as plus infinity. That's the standard normal variate. And what we need is minus 0.2 to 0.6. Minus 0.2 comes on the left side, minus 0.2, and 0.6 comes on the right side, 0.6. We need between that area. So area what is required is this region which is from minus 0.2 to 0.6. This is the region which we call it as probability. So this is what we need, minus 0.2 to 0.6, for which they have given the number area from Z20 to Z22. That means 0 to 0.2 they have given, but I can take a 0 to 0.2 as 0 to minus 0.2 also. That is 0 to 0.2 is right side and 0 to minus 0.2 is left side. Symmetrical property, the right side area, the left side area will be equal. So this region is given as 0.0793. The left side region is given as 0.0793, and 0 to 0.6, that is given straightforward. 0 to 0.6, the region is 0.2257. But I need both region, so we are going to do sum. That is 0.0793 plus 0.2257. So add both the regions. 0.305. It's probability. But the question is not probability, question is What is the number of students and how many students are there? Totally there are 800. Probability is 0.0305. So multiplied by 800. That will give you number of students. If the probability was asked, answer is 0.305 multiplied by 800. That is 244. Okay, next one. And last one of this chapter, tricky one. Again, exam question. The IQ of army volunteers in a given year are normally distributed mean 110, that is mu. Standard deviation is 10, sigma. Army wants to give training to 20% of those with the highest scores. That's the interesting information. The probability they only have given 20%. They are not asking you to compute probability. They said they wants to have 20% of the people. So probability is 20%, proportion 20%. What is the lowest IQ acceptable for advanced training? So what should be the X value such a way that we get the probability? So what we calculated in the previous problem, they had given X. From X, we convert that into Z value, and from Z value, we calculated the probability. In this problem, probability is given. We have to work back towards Z value, and from Z value, we should come to the X. That is what is required. That is given. We'll take help of Z. That is the number which will take help, and we should get the answer as X. Yes, for that 0.3 Z area is given. That's a hint we can definitely make use of. But we should know what is at 0.3 also. So we'll calculate that. So probability of X more than some number, I don't know that number, let me call it as X1. This should be equal to 20%, that is point. The probability is what? Should be point. And how do we convert from X value into Z values? So we'll subtract mean. So X minus mean is given 110. Divided by standard deviation, also given 10, greater than that X1 value I don't know. That's what I have to calculate. X1 minus 110 divided by 10 should be equal to 0. Or this we'll call it as, this is anyway Z, greater than. This number I don't know. Let me just call it as K or something, some constant number. I don't know that value. We'll just call it as K is equal to 0.2. So what this number means, what we just calculated, if I plot on graph, okay, assume it's a normal curve, hope it looks like that. So 0, minus infinity, plus infinity. We have to start from K and greater than means we'll have to go right side. Right side is greater than, left side is lesser than. So if I plot somewhere here K, and greater than means it will go right side, this region. And this region is given, we don't have to calculate. The right side region is 0.2. That's what we have written. The right side region greater than K. After K, the region is 0.2. And we would have given something in the problem. What they have given? The value of Z for the area 0.3. It means, again, if I plot one more graph, 0, minus infinity, plus infinity, area 0.3. That is from starting from 0 till this region is 0.3. And what this region, I mean this number is 0.84. So this region from 0 to 0.84 is given as 0.3. Okay, now you compare the two, you will be able to get the k value, because when k to infinity is 0.2, what is 0 to k? 0 to k must be 0.3. Why is it 0.3? Because 0 to infinity represents half of the curve. Half means 0.5. So 0 to infinity is 0.5. This region is 0.2. So remaining region should be 0.3. So you compare the two graphs. This also is 0.3. This also is 0.3. Here it is 0.84. Here it is k. In other words, the k value is 0.84. And k is this one. X1 minus 110 by 10 is 0.84. So cross multiply, we'll get the value of x1. That is 10 into 0.84 is 8.4. 110 goes to right side, becomes plus. So 110 plus 8.4 is 118.4. So this is the reverse calculation from probability. We calculate Z. Okay. So this is about theoretical distributions. Two chapters are there. One is very important one, which is correlation regression, and another one small one, which is index numbers. Okay, so we'll take it up after the break. So take a break of 15 minutes, 3:35 now. So let's meet at 3:50. We may go up to maximum 5:15, not beyond that. I'll try to finish before that, but maximum will be 5:15. You need to have, because I don't want to do it at a continuous stretch. So take it break, that's fine. Just 5:15, it will not be more than that. I might finish at 5 o'clock only, that I'm not sure, but just tell you so that you are be prepared. So two chapters are there, we'll take it after the break. So come back at 3:50, 15 minutes. Okay, so next chapter, correlation and regression. So talks about two areas. About correlation measures the extent of relationship, whereas regression measures the average relationship. The difference is, actually we express something like R. Correlation, if R is less, for example, if I tell you 0.8, it means that there is 80% chance variable move in same direction. If I tell R equals to minus -0 0.8, that means variable will move in opposite direction. But we cannot tell if one variable changes by 1%, by how much another variable will change. That is obtained under regression. So correlation will tell you whether two variables are related or not, whereas regression will tell you if I know one variable, I can predict, estimate another variables. So correlation cannot be used for predictions, regression can be used. So correlation talks about two aspects. One is direction and the degree. Direction means whether positive or negative. Degree means whether low correlation or higher correlation. It varies from -1 to +1. Correlation coefficient cannot go below -1 and it cannot go above +1. -1 is called as perfect negative and +1 is called as perfect positive. Around -0.75 we say high negative, around +0.75 high negative, high positive, around -0.5 moderate, around 0.25 we say low correlation. So just like how it happens in your life also, what happens at your home is perfect negative, because whatever they tell you do opposite only. That's your age, can't tell. They tell don't eat outside, you will eat outside only. They tell come home early, you will not do it. They say don't go outside, don't spend too much on mobile phone, you will do it. Or whatever they tell, for the sake of it you do opposite, because life is perfect negative. And what happens with friends is perfect positive, because whatever the friend will tell, you say yes. We'll go for movie, yes. We'll go outside and have food, yes. For a change, we'll go to class, yes. We'll go to home and we'll go to class and take rest. It's too hot outside. And that too, if it is, girlfriend, boyfriend, then perfect correlation. You don't have any difference of opinion. And between -1 to +1, that is between your friends and home, then there is 0, which is called as classes, college, whatever you call it, where there is no correlations. Did you understand? No reaction. Not understood? No reaction. You come, sir, you sit, sir, you go, sir. We come, sir, we sleep, and we go, sir. There is no correlation between what we discuss and what you understand. Anyway, so remember, correlation goes between -1 to +1. Measurement wise, we have broadly 4 methods. One is scatter diagram. With the help of graph, we identify both linear, non-linear. Then we have most important one, which is Karl-Pearson's correlation. Formula is given by covariance by standard deviation of x into standard deviation of y. And what is covariance? That is summation x minus x bar and y minus y bar. We multiply both and divide by n. And one shortcut formula is also there. But important one is this: covariance by product of standard deviations. Rank correlation also there, Spearman rank correlation, that is 1 minus 6d square by n into n square minus 1. N is number of observation. D represents a difference in ranks. So advantage of rank correlation is you can also use it for attributes, which is not numeric. You can still calculate rank correlation. Concurrent deviation, that is not important much, so we'll not focus on that. What is important is the Karl-Pearson's, and to an extent you can say Spearman's, rank correlation. And what is most important next is regression. As I told you, regression can be used for estimations. If I know value of one variable, we can estimate another, and that's why we call it as line, regression line. Of y on x means y is depending on the value of x. So if I know the value of x, I can compute the value of y. So the formula looks like this: y equals to a plus bx. A is the constant, b is the coefficient. So b is also called as regression coefficient. R is called as correlation coefficient. And how do we calculate this B value? Is given by R into standard deviation of Y by standard deviation of X. Remember like this, because you'll also get one more set of formula which is X on Y. Both can be confusing. Keep it very simple. When it is Y on X, Y will be on the left hand side, X on the right hand side. Y is depending on X. And second point, whenever it is Y on X, Y is numerator, X is denominators. Y on X, name itself tells, Y is above numerator. One more formula is also there that I don't give much importance, but this one you have to remember, R into standard deviation of Y by standard deviation of X. And A is A bar minus B into X bar. This looks like a formula, but don't remember like a formula. You just rearrange this only. What equation we have? Y equal to A plus B by X. You bring the B by X to left side. How the formula will look like? It is Y minus B by X into X, and that's what formula we have. Y bar minus B into X bar. So you just bring this B by X left side. You get the value of A, and formula for A. You don't have to remember it specifically. Regression or line on X and X on Y, Y on X, they are separate. Y is depending on X, one line you get. X depending on Y, one more line you get. And you just interchange X and Y values, you get the new equation. But the most important from this chapter, I would say, this list. Each property here can be converted into a question in exam. These are the properties, you have to keep it in mind. If R is equal to 0, lines are perpendicular. What lines? That is X on Y, Y on X. If R equal to plus 1, if R equal to minus 1, in both cases, lines will coincide. That is X on Y, Y on X, both become same in situation where R is perfect correlation, positive also, negative also. And R is given by square root of Bxy into Byx, or we call it as correlation coefficient is geometric mean, square root of regression coefficients. Bxy is one coefficient, Byx is another, multiply, take square root, what you get is R. The most important formula is this. And all the three will have same signs, which means Byx, Bxy and R, all the three will be positive or all the three will be negative. This is like, corona. If one person gets in the family, everybody gets. So like this, that is Byx, Bxy and R, all the three are positive or all the three are negative. One positive, one negative, that cannot happen, at least mathematically here. And one more important is, lines will intersect at X bar, Y bar. Two lines we have, Y on X, X on Y. The two lines will intersect. The point of intersection gives you X bar and Y bar. And mathematically, how to solve the point of intersection? By solving simultaneous equations. So two equations given, solve for simultaneous equations, value of X and Y, what you get, that is nothing but X bar and Y bar. One more important variety they will ask in the question, that is they'll give you two equations and they'll ask you which is Y on X and which is Y on X on Y. That is one popular question. We will address it slightly later. So quickly run through the theory, then we'll take up the problems. Okay. Let's quickly look at that one I told you. Oh, one more point I have to tell you. That is correlation is independent of change of origin as well as scale and independent of unit of measurement. So what is this change of origin, change of scale means? Whether you add all the observations or subtract, correlation does not change. More importantly, if you multiply all the observations or divide also, correlation will not change. It is independent of both, but it is not independent of sign. That minus can become plus, plus can become minus, but the value of correlation does not change. Whereas regression, it is like dispersion. It is independent of origin, but dependent on scale. Okay. So what is the most important variety in this problem? Is this question I told you to find x on y and y on x. There is one method being followed, but I'll try to follow slightly differently. See, they'll give you equation like this. For example, they'll give you 2x plus 5y minus 9 equal to 0. This is one equation. Another equation, 3x plus y minus 5 equal to 0. And now they'll ask you which is x on y, which is y on x. See, if y equal to something, I'll say y on x. If it is x equal to something, then I can say x on y. But they're given x plus y, x plus y. How do I say which one is x on y, which one is y on x? So first one is what one then? Y on x. Don't express your feelings and all here. So that's, I feel first one is x on y. Feeling will never be correct in exam. So facts are always different. So, I mean, there are methods. I'll try to give a shortcut. So first thing, keep it very simple. Find out the ratio of x is to y. And here you write down y is to x. So what's the ratio of x is to y? Coefficients 2 is to 5. And what is the ratio here? Y is to x. Always do opposite. X is to y, other is x, y is to x. That is 1 is to 3. And you take the, I mean, 2 is to 5 means 2 by 5. 1 is to 3 means 1 by 3. You multiply both and take square root. That is what gives you r. So how much you get? 2 by 5 into 1 by 3 square root. After square root, zero point 2 by 5 into 1 by 3 square root. 0.36. Okay, 0.36. So r is valid r, means between -1 to +1. So my assumption is correct. In the sense, I don't have to make any change. If they ask you question in r, I got the r. If the question says using these two equations, find correlation coefficient, we got it. But they'll ask you which is y on x, x on y. Just be careful here. What is the ratio we have used? X is to y. X is to y means this is y on x. And this is y is to x. And therefore this is x on y. Over. That's all the answers. We don't have to do any other calculation, any other steps. Take one ratio, another ratio, multiply, square root. If your answer is valid r, that's all. X is to y, you take it as y on x. Y is to x, you take it as x on y. Then when will your answer change? See, instead of 0.36, if the answer is 1.15. If answer is 1.15, r is not correct r. Because r cannot be more than 1. So what you should do, if the answer comes like this, you take a reciprocal of this. So correct r will be 1 divided by 1.15. Then what is the interpretation? Actually x is to y is not correct. We have to make it as y is to x. So what is the conclusion on this? If our assumption is correct, x is to y is y on x. If assumption is not correct, then x is to y is x on y. Okay, I'll just give a simple chart. You try to calculate. You calculate r by assuming something. Two things can happen. R is less than 1 or R is more than 1. In our example, what happened? R is less than 1. So R is less than 1. I don't have to do any change. So x is to y. Whatever we have assumed x is to y is actually y on x. And one calculation you identify sufficient. Another equation you don't have to say. Because one equation y on x means other one is automatically y on x. I mean x on y. You don't have to remember both. Just identify one of them sufficient. So when I say R is correct, no other calculation required, x is to y is y on x. Other situation, r is greater than 1, in that case what do you do? Whatever you have assumed x is to y, that is actually x on y, opposite basically. And if you want correct r is nothing but you take a reciprocal, you get the correct r. So this is all the formula required, I mean the shortcut required. And this is one typical problem they'll ask. When we solve the problems, you'll be able to understand. Okay, let's apply this. Let's see to what extent you're able to follow. Let's solve problems. Okay, dash gives mathematical relationship between two variables. It is regression. Correlation will not give mathematical relationship. What does correlation does? It just identifies. And what is mathematical relationship? Mathematical relationship means equation. A straight line equation, quadratic equation. You say y equal to something. I mean, whatever equation comes, here we call it as there is mathematical relationship. And in correlation, we don't have a formula for any equation. Only regression we have y equal to a plus bx something. So equation exists only in regression. So mathematical relationship exists only in regression. Can be confusing question, be careful. Correlation coefficient between x and y will be negative. When? Negative means not both are decreasing. Both are decreasing means same direction. Negative means they move in opposite direction. One increasing, another decreasing. So it's option B. When one variable increase, other variable decrease, that is when it is negative correlation. The coefficient of correlation between x and y given. So they have given variance. But what is the formula for correlation? It is covariance divided by standard deviation of x into standard deviation of y. So for that what do we do is variance we take a square root. What they have given variance is 2.89. Square root of variance. So standard deviation is square root of 2.89. It is 1.7. And standard deviation of y square, variance is given as 100. So square root of 100, that is 10. Now substitute standard deviation 1.7, another standard deviation 10, covariance given as minus 16.5. Minus 16.5 by 1.7 into 10. So minus 0.97. These are all simple chapters, should not be complicated, so make use of this. Some basic formulas and properties, and questions will be revolving around those properties only. Okay, next. Two random variables are given, coefficient of correlation between x and y. Not correct, not coefficient of correction, that's a typing mistake, coefficient of correlation. See, this is what I'm telling you. Typically, they'll give you two equations, ask you to calculate the correlation. I told you what is the method. You assume x is to y and another one is y is to x. So what is x is to y for the first one? 3 is to 2, and you assume y is to x. Another one is y is to x, that is 1 is to 6. Then what do? 3 is to 2 means 3 by 2. 1 is to 6 means 1 by 6. Multiply, take the square root. That is what is R. Point 0.5, right? 0.5. So I don't have to change anything. Answer is 0.5 only. If answer was more than 1, then I'll take a reciprocal. Just multiply and take square root. Okay, one small thing I did not tell you, I'm telling you now. Whether it is plus zero point 0.5 or minus 0.5, that is slightly tricky. Observe. You should look at between x and y, whether it is plus or minus. Between x and y it is plus, so answer is minus. It is opposite. That's the only shortcut, you have to keep it in mind. Between x and y, if it is minus here, then I'll write it as plus. So when you are calculating the correlation coefficient shortcut, be careful. Between x and y, plus means correlation is minus. So answer is C. The reason is very simple. See, when you have 3x plus 2y, when I take 3x to right side, that plus 3x becomes minus 3x. So coefficient is minus. That's the logic. Anyway, shortcut you remember, between x and y, if it is plus, correlation is minus. That is a wrong question because we discussed, right, corona. The standard deviation, that is correlation coefficient R and Byx and Bxy. All the three will be positive or all the three will be negative. So conceptually, this is plus means this should be plus. 1 plus 1 minus. If it happens, that is purely a conceptual mistake, error in the question. Next one. Two regression lines are given. We find regression line of y on x. Okay, here we don't require r, but we still have to calculate. So x plus 2y. So what shall we assume? X is to y. That's what we assumed earlier also, right? Start with x is to y. And second one, you take it as y is to x. So what is x is to y means? 1 is to 2. And what is y is to x? 3 is to 2. So 1 by 2 multiplied by 3 by 2. Then take a square root. So what do you get? 0.866. Okay, 0.86. Now this is less than 1. So I don't have to change anything. And in that case, x is to y is how it is to be interpreted. X is to y is actually y on x. If it was 1.86, x is to y, I'll take it as x on y. That's the only change. We have written the chart also earlier based on that. My assumption is correct. X is to y is y on x. When r is less than 1, I don't have to make any change. So answer is this. Y on x is option A. X is to y is y on x. Okay, next. Two regression lines are given. Value of correlation coefficient. Again, the same shortcut. I'm solving so many problems because they have asked in the problem also many times in exams. X is to y. Here we write 16 is to 20. Here y is to x, which is 30 is to 80. So 16 by 20 multiplied by 30 by 80 square root. This also less than 1. 0.54. 0.54. And we just have to be careful whether it is plus or minus. Look at between x and y. We have minus, so answer is plus. So plus 0.54. Anyway, minus option is also not there, but just to be on safer side. Next. The two regression equations are given, correlation coefficient x and y. Okay, this you calculate. Same format, you one ratio is x is to y, other ratio is y is to x. Multiply and take square root. Okay, so x plus y means ratio is 1 is to 1. X plus 2y means ratio is 2 is to 1. So what will be the answer? 1 is to 1 is 1 by 1. 2 is to 1 means 2 by 1. And multiply, take square root. I think you get more than 1. Actually, is root of 2, 1.4 something. So the answer is reciprocal of this. Reciprocal is 1 by root. Root 2 is not the answer because more than 1, you take a reciprocal 1 by. Only thing to be careful is it plus or minus. Between plus and plus, we have plus. So answer will be minus. So it will be minus 1 by root. Root 2 cannot be the answer because root 2 means more than 1. So you take a reciprocal. So whenever that ratio, we take it as more than 1 or you take a reciprocal to get the answer. Okay, next. Two variables are given, correlation between x and y. It's a very interesting one. Usually we used to see so far two equations were given. Now only one equation given. And only one equation will happen in which situation? Lines will coincide. X on y, y on x. Only when the correlation coefficient is perfect. But perfect correlation happens in two situations. R equal to plus 1, R is minus 1. But which one in this case right? Between x and y it is plus. So actually it should be minus. So perfect negative, which actually means R is minus 1. So you can see nothing to calculate, just observation. Correlation coefficient between x and y is 1. Correlation coefficient between x minus 2 minus y by 2 plus 1. Okay, this one, be careful. This is based on the concept of change of origin, change of scale. X value here and here x minus 2, which means all the observations of x is subtracted by 2 and correlation coefficient does not change. What about y? All y values are divided by 2. Correlation coefficient does not change. But one thing is there, coefficient you have minus. So you can see coefficient of x is plus, coefficient of y is minus. So when 1 plus 1 minus, correlation coefficient number will not change, the sign will change. So the sign instead of plus 1, it becomes minus 1. If it was plus 0.68, it will become minus 0.68. And why is it the case? Because the sign is opposite. Coefficient of x is positive, coefficient of y is negative. So that's why I told you correlation coefficient is independent of origin, independent of scale, does not change, but is dependent on sign. So positive becoming negative, it was negative, it should have become positive. By comparing the coefficients between x and y, the answer is just minus 1, nothing to calculate. Okay, next. Sum of product of deviation of x and y from their means is 0. Correlation coefficient will be. Again, you see they have given sentences, convert that into a equation format. Sum of, summation, product of, product means we multiply two things. Of what? Deviation from x and y. Deviation of x and y from their mean. That is the deviation from x is x minus x bar and deviation from y is y minus y bar, and this is given as 0. And what is the formula for correlation coefficient? R is covariance by standard deviation of x into standard deviation of y. And what is covariance? Covariance is this formula only. Summation x minus y bar, x minus x bar, y minus y bar divided by n. Now if x minus x bar, y minus y bar, this is 0. Anything you divide by n, n does not matter. Covariance will definitely be equal to 0. And if covariance is 0, what you divide by standard deviation does not matter. R also will be equal to 0. So R is equal to 0. Okay, next. If two variables are uncorrelated, uncorrelated means R is 0. You can say uncorrelated, not related, or independent, all are same. Not correlated, R is 0, and when it is R is 0, the regression lines becomes perpendicular. I told you each of those property can be made into a question here. And when it is R equal to +1 or -1, the line will become same. They coincide in the case of perfect correlation. So R is 0, lines becomes perpendicular. Option B. The covariance between two variable is positive, negative, always 0, either positive or negative or 0. It is option D. Covariance means that is summation x minus x bar into y minus y bar. This number, divide by n, of course. This can be positive number, negative number, 0. This can be any number. So option D. Covariance can be any number, no restriction. Correlation has a restriction. Correlation is always between -1 to +1. Probability has a restriction. Probability is always between 0 to 1. But covariance, no restrictions. It can be any number. What are the limits of correlation coefficient? Just now I told you it is -1 +1, including the limits. It can be -1, which is called as perfect negative. It can be +1, called as perfect positive. So option D. The rank of 5 participants given by 2 judges are given. We have to calculate rank correlation coefficient. One method is there. Using the formula I can calculate. Let's do it. Use the formula. Let's calculate. They have given R1. Yeah, we had. So we'll be able to definitely do it. But we'll just quickly do all using formula also, just for verification purpose. So rank 1, rank 2 they have given. So what you calculate is difference in ranks and square it. So what is difference in rank? 1 minus 5, you get 4 and square it. 4 square is 16. And 2 and 4, the difference is 2, square it. That is 4, 3 and 3, difference is 0, 0 square is 0. 4 and 2 square is 4, 5 and 1, 4 square is 16. So add all these numbers, you get summation D square. I think 20 plus 20, 40. Okay, the correlation coefficient is given by 1 minus 6 D square divided by n into n square minus 1. So 1 minus 6 into 40. N, number of participants, 5 participants are there. So 5 into 5 square minus 1. So 1 minus 6 into 40 is 240. 5 square minus 1, 25 minus 1 is 24. So 5. So is 40 correct total? Okay. 5 square is 25. 25 minus 1 is 24. So 5 into 24. So 1 minus 240 by, I think this is 120. And when you get the, if you simplify 1 minus 2, you will get the answer as minus 1. And actually we don't have to calculate like this, because if you observe, it is 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1. So exactly opposite taste, and opposite taste means you get minus 1. Maybe the two judges are husband and wife, so their taste is exactly opposite. So correlation coefficient is perfect, minus 1. Okay, next one. In case of insurance companies, profits and number of claims they have to pay will have a positive correlation, negative correlation, no correlation, none of this. What is the meaning of claims? What insurance company have to pay? From insurance company point of view, that is a payment. So when you have more payments, what will happen to profits? Profits will come down. So claims is more, profits will come down. They are moving in opposite direction. Opposite is negative correlation. Which of the following is true? R into bxy. Okay. So what you should remember, bxy means it is x on y, and when it is x on y, x will be on the numerator. Actually, y is on the numerator, so A is not correct. Look at B, byx. So y is on the numerator, yes. Standard deviation of y by standard deviation of x. So B is correct. When it is yx means y on x, and y is on the numerator. Whichever comes first, that is on numerator. So option B. bxy, byx are 0, then r equal to 0. I told you, Corona, byx, bxy and r, all the three are zeros, all the three are positive, or all the three are negatives. All the three will have same signs. So if one of them is 0, if they say two of them are 0, r has to be 0. Byx is 0, bxy is 0, r is also 0. X bar given, y bar given, regression coefficient of x on y. Okay, this we have to calculate. Regression coefficient means b. X on y means we have to calculate xy. X on y, xy. And the r will always be there. X on y means x will be in the numerator on y, so y will be on the denominator. R is 0.6. Standard deviation of x 16. Standard deviation of y 9.6. So 0.6 into 16 by 9.6. Sorry, standard deviation of x is 4.8. No? Standard deviation x is 4.8 and standard deviation of y is 9.6. Yeah, 4.8 by 9.6. You get 0.3. Okay, next. XY denotes arithmetic means sigma x, sigma y is standard deviations. Byx, bxy denotes regression coefficient of variables x and y respectively. The intersection point of regression line of x and y is, intersection point is x bar, y bar. I think in the material that bar is not printed. I think it's some colon or comma is there in the material. Just correct it. It should be x bar, y bar. The intersection will result in arithmetic means. Intersection point is here called as arithmetic mean, x bar, y bar. The two lines intersect at arithmetic means. So option A. If the value of correlation coefficient is positive, then the points in a scatter diagram tends to cluster from lower left to upper right, from lower left to lower right, lower right to upper left, lower right to upper right. Okay, let me show how it looks like first. Positive means it starts from left side and it goes to upper side like this. So that is what is positive correlation. If it comes down, that is negative correlation. So it starts from the lower left and move towards the right upside. So lower left to the right upper side is option A. Lower left and move towards upper right. Upside as well as right side. That is what is positive correlation. Okay, so this is about correlation regression, and most important area being that x on y, y on x. That is the repeated asked questions from exam point of view. Okay, last chapter, index numbers. No, you don't have time series. It's not there in the syllabus at all. In the material I've included? I thought I've excluded. Oh, time series. Okay. Sorry, I think I should have excluded that portion. I thought I excluded. No, it's not there. That by mistake I've included. So time series is not there, and also in mathematics, I think I've included by mistake matrices. That is also not there. Yeah, that was not there originally. Then they added, then they removed again. So it is not there. So ignore both of them. Matrices and time series, not there. Only we have index numbers. Okay. Index numbers are basically a special average. It actually represents between the two times how the price have been increased. For you to compare the price between two periods. I'm sure you would have heard this from your parents like this. When you say I want to go for a movie, 1,000 rupees means they'll be like 1,000 rupees. In our days, my monthly salary used to be 1,000 rupees. That's a common statement, and you will also tell. You will also tell to your children the same sentence you write in your book, and later you see it. You will tell the same thing. So when your children will ask you, no, how much you think they will ask you? 10,000 is very small. They'll ask at least 1 lakh and all. After 20 years, that will be the price. Now the popcorn price is almost 1,000 rupees. 10 years back, the popcorn price was just some 100 rupees or 50 rupees. It's increased like 10 times. So same thing will happen. Now 1,000 rupee, 10,000 will become 1 lakh. In 20 years time, it will be easily. Anyway, then you will also tell the same thing. In our time, it was just 1,000 rupees. Now you're asking for 20, 30,000 rupees. You will tell the same thing. But for you to compare between the two periods, that's what is called as index numbers. Index numbers, the base is always 100 because we express it in percentage terms. The base is always 100. And we have some 4 tests to learn and some application problems you have to understand. So index number is specialized average. For calculation, we have 2 methods. One is unweighted, means we don't take quantity. Weighted means we take quantity. Unweighted method, we have one is simple aggregates, other one is simple relative. Let me show you some quick example. If the price is increased from 80 rupees to 90 rupees, so how much is the increase we say? It is 10 rupees. But what is the percentage increase? It is 10 divided by 80 into 100. But rather than calculating like this, what index number we do is like this: P1 by P0 into 100. P1 is the latest price, 90. P0 is the previous price, 80 into 100. Thus give you, I think, 112.5, something like that. So basically means if I start with 100 rupees, it would have become some 112 rupees in the next year, in the terms of percentage. Simple aggregate means we have individual prices, you add all, simple aggregate method. Simple relative method means we calculate the index number for each of the products. For example, you might have rice, you might have sugar, you might have clothes, you have house, different prices are there. You calculate index number for each of them, and then we take an average. That's called as simple relative. And popularly we take simple average, that is arithmetic mean, but most appropriate is geometric mean. And weighted method means we also take quantity into consideration, so it's called as weighted methods. We have 4 methods are there. Importantly, I know many are there, but these are the 4 important ones: Laspier's, Paget's, Fisher's, Dorbish-Bowley. So what Laspier's does is, basic formula is same, that is summation Pn by P0, means current price by base year price. But what you multiply For last years, you multiply it by base year quantity, Q0, Q0 each. And for Paasche index, you multiply it by current year quantity, that is Qn, Qn each. And Wishers does the geometric mean, so it multiplies last years and Paasches and takes square roots. And Dorbish-Bowley take a arithmetic mean, that is L plus P divided by 2. We have 4 tests to test the adequacy of index numbers. One is called as unit test. The index number should not contain any units. In fact, all of them satisfy except simple aggregate method. Time reversal test means normally we write P01, and if I multiply with P10, 01, 10, if I interchange, that answer should be 1. That is satisfied by Fishers, not last year's and Paasches. And factors means price and quantity. If I interchange, that should give me value, and that is also satisfied only by Fishers. Circular test is an extension of time reversal test. Time reversal we took only P01 and P10, but you extend this to many years. That is 01, 12, 23, then come back 32, 21, 10, and when you multiply all of them, that should be equal to 1. Circular test not satisfied by any of these index. Anyway, so application problems, sometimes they'll ask you this chain index problems, not very frequent, but you should know. Okay, before chain index, I'll tell you link relative. Link relative is calculated by current year price by previous year price. So what is the difference between link relative and basic index numbers? In basic index number, also current year price, but we don't divide by previous year, we divide by base year, and base year is always fixed number. And when we calculate link relative of current year and chain of previous year, using that you can calculate chain index, not very important, so you can ignore that for the time being. A deflating time series is also called as finding the real value. A real value means going backwards, that is current year price divided by the index number. So 10 years back, what was the price? Using the index number, you can calculate at that point in time how the salary was calculated and how much it was, like that. Anyway, so go through this theory part quickly for 5 minutes, then we'll look up the problems. If you have any doubts in any of these formulas to be explained. Okay, so let's take up problems. P10 is the index for the time 0 on 1, 1 on 0, 1 on 1, 0 on 0. It is 0 on 1. You have to read from right to left. That is like a Urdu style, you have to read right to left. 0 on 1. So option A. Last year's is 90, Paasche is 160, Fisher's is geometric mean, so you multiply and take square root. Fisher's is last year's into Paasche square roots, so 90 into 160 square root. 120. Next. Consumer price index number in the year 1957 was 313 with 1940 as the base year. Average monthly wages in 1957 of the workers in the factory 160. Their real wages is, actually we have to do deflate it, but let's not use any formula. Let's simply use the cross multiplication method. In the year 1957, so we have year 1957 and 1940. Index number. Index number they have given as 313 with 1940 as the base year, and base year index number is hundreds. That is implied. And they have given wages. Wages in the year 1957 is 160. So what are the wages in the year? 100. You simply cross multiply 100 into 160 divided by 313. So 51.12. So that is what's the equivalent wages those many years back. Okay, next. Dash play a very important role in construction of index numbers. I think it should be calculator, no? Without that, how do we calculate? Anyway, yes, weights are also called as quantities, play an important role. Option A. Factor reversal test is, factor reversal means the price into quantity were interchanging, that should give you value. Value means P1 Q1 by P0 Q0. That's what is value. Price into quantity is called as value. So P1 Q1 by P0 Q0, that is what is option A. P1 Q1 by P0 Q0. If a rise of 10% wages are increased by 20%, the real wages are increased by so they are telling very simple thing. Prices are increased by 10%. Wages are increased by 20%. The real wages means your savings will actually be less than 10%. I'll show you how. When I say raise of 10%, if I start with index number of hundreds, what will be the new index number? 100 will become 110. That is what increase of 10% means. What about the wages? Wages, if I start with 100 rupees, it is increased by 20%, so it is 120. Now I want to express it in real wages. What do you mean by real wages? I'll have to compute backwards. So cross multiply this. 120 into 100 divided by 110. What is the real wages? Cross multiply 120 into 100 by 110. 109.09. So actually in real terms, wages are increased by 100 to 109 means 9.09. That is a real increase. That is what it is, less than 10%. Wages, you calculate the real wages. Real wages means you go back and calculate and then compare with 100. That will give you the actual real increase. So from 100 to 109, increase is 9.09 and 9.09 is less than 10. Okay, next. PNQ0 is 1180, P0Q0 1170, PNQN is 1064, P0QN is 1100, Fisher's index. Okay, so Fisher's index is given by L into P, square roots, and what is L? That is last year's is they take Pn Q0 divided by summation P0 Q0. So last year's will take Q0 Q0, that is base year quantity. Whereas last year's, Pacius considers price is same only Pn and P0, but instead of Q0 they consider Qn, and those values are given. PNQ0 is 1180. PNQN is 1064. P0Q0 is 1170. P0QN 1100. So PNQ0 1180 multiplied by, of course, ultimately you can multiply it by hundreds. 1180 into PNQN 1064 by P0Q0 1170 P0QN 1100. Of course, you multiply it by 100 so that you express in percentage. 98.77. Okay, next. When the prices are decreased by 30%, the index number is now becomes, the base year number is always 100. If that is decreased by 30, 100 minus 30, that becomes 70. Decreased, so minus. Circular test is satisfied by index number, last year's, Pache's, Fisher's, none of this. And what is circular test? I'll quickly revise. It is P01 into P12 into P23 dot dot dots. You can go for n number of years, then start reversing it. Means P32 multiplied by P21 and 10. That should ultimately give you 1. If that is satisfied, that's what circular test. None of these index numbers will satisfy circular test. So none of this. Fisher's index number is dash of last year's and Pache's. Fisher's index number is geometric mean of last year's and Pache's. Multiply, we take square roots. So it's geometric mean. Arithmetic mean is Dorbish-Bowley. L plus P divided by 2. That is Dorbish-Bowley. Which of the following statement is true? Pache's index number is based on base year quantity. It is not correct because they are depending on current year. Last year's is based on base year. Fisher's index number satisfies circular test? No, it does not satisfy. Arithmetic mean is most appropriate for index numbers? No, it is geometric mean. Because here we talk about the increase, percentage, ratios. And for ratios, what is most appropriate is geometric mean. Splicing means constructing of one continuous series from two different series from the common base. Yes, splicing means basically combine. We have one series with one base year, another series, another base year, we can combine them. That combination is called as splicing. Monthly salary of an employee was 10,000 in the year 2000. And it was increased to 20,000 in the year 2013, while the consumer price index number is 240 in the year 2013 with the base year 2000. What should be salary in comparison of consumer price index number in the year 2013? They are giving salary and all, somebody else personal information, but we have to calculate. So we can't say their personal problem and leave it. Year, they have given 2 years. One is year 13 and year 2000. So let's write it, year 2013 and 2000. And they have given index numbers. In the year 2013, consumer price index number is 240. And in the base year always means hundreds. And what should be the salary? And what was the salary earlier? In the year 2000, his salary was 10,000. So what should be the corresponding salary now? If he has to maintain same standard of living, cross multiply 240 into 10,000 divided by 100. So you get 24,000. Okay, that's what they asked actually. What should be his salary? His salary should be 24,000. But if they ask one more question, what should be the increase in salary? Then from 10,000 to 24, then increase should be 14,000. Or if they ask what should be salary from current level, then from 20 to 24, then that increase would be 4,000. So accordingly, whichever is the question they asked, and depending on that, we will change. Okay, so after this, which chapter? So shall we do ratios or equations? Yeah, so we'll have to decide which one shall we do, ratios or proportion, because I told you, no, we'll have time till 5:15. Tomorrow also we'll do. I'm not telling tomorrow we will not do it. So I told you, we'll extend the class till 5:15. It's fine, just 15 minutes. That's all. No, tomorrow we'll talk about tomorrow. We'll not mix it today. I understand, see, different kinds of reactions I get, no? So for that, sometime ask. So some people will be like, it's okay, extend. Some people will be like, whether you extend, you don't extend, does not matter. You do whatever you want. And some people are so innocent look, as if they don't know anything. And the best part is some people have warning look. Sir, you come outside, we'll see what happens. Okay, just to be on safer side, we'll stop at this point. So statistics we completed. Tomorrow we'll continue with the mathematics parts. So we'll see you tomorrow, same time. Take care. Bye-bye.